Namaskar everyone. My dear students, I welcome you all to this GATE through question series and today we will be discussing some wonderful questions मैंने आप लोगों के लिए प्लान किए हैं आज just to give you a very holistic view of fluid mechanics for your GATE examination. I have tried my level best कि मैं ऑलमोस्ट हर टॉपिक, इसको आप क्वेश्चन सीरीज कह लो या एक प्रकार का रिवीजन भी कह सकते हो, यू कैन से इट एज अ रिवीजन ऑल्सो बिकॉज ऑलमोस्ट ऑल द वेराइटी, इंपॉर्टेंट वेराइटी ऑफ formulas that are used in the subject, we are going to look into the questions and the numericals related to that. So therefore I have tried my level best to include almost each and every important topic of fluid mechanics so that we are able to enjoy today's session in depth, in detail. Okay, but I have chosen a lot of questions so time might become a constraint, but let's see how much we will be able to do because I had planned in such a manner that approximately for the next 3 hours or 3.5 hours, something like that, we are going to continuously go for beautiful set of numericals in fluid mechanics. So yes, it is going to be a long session. आप लोग बकअप हो जाओ, पेन और A4 साइज के कागज अपने पास रखो या कोई भी रफ कॉपी अपने साथ रखो. You take it with you, have your calculator by your side. आज हम फोड़ फाड़ के ही निकलेंगे यहाँ से एंड बहुत सारा इंजॉय करके निकलेंगे, बहुत सारे कॉन्सेप्ट्स को रिवाइज करके ही यहाँ से निकलेंगे. ठीक है, सो अपना कॉपी पेन रजिस्टर और कैलकुलेटर अपने साइड में ही रखिए. द क्वेश्चंस आर गोइंग टू बी देयर ऑन द बोर्ड. आई एम गोइंग टू सॉल्व अ लॉट ऑफ क्वेश्चंस. Few questions I am just going to give you the hint where I feel that okay, you guys are confident enough and yes, we can move forward. So in those variety of questions I will just give you the hint and the answers. Okay, another important thing is that kindly do not leave the session in between. The reason being that the complete session itself is very important because I have covered each and every topic. Okay, so let's enjoy. Read the questions carefully which will be coming on the board. So first 30 seconds I will give you to read the questions properly, then we will go for the solution part. If you are confident enough that yes, I can solve this question, okay, then you carry on. Don't wait for me. Okay, you carry on, apply the formulas, revise with me, and then when I write the final answer after the complete solution, then you check your answer. Okay, so this way we are going to move forward today. And one more important thing, let me tell you guys that after completion of the all the questions, what I am going to do is I am going to step aside the board. मैं board से side हट जाऊंगा, ठीक है, and I am going to move the slider so that you can take the screenshot from the recorded version. Okay, so this is not a live only session. The video will be available throughout. Okay, so don't worry about anything at the moment. Let us get all concerned about revision, speed, accuracy, and let us enjoy science. Let us enjoy science, my dear students. Okay, so yes, and one more thing, this session is common to both mechanical and civil engineering student. So it doesn't matter whether you are a mechanical engineer or a civil engineer, this session is important to both the branches. And yes, one more last announcement, then yes, I'm not going to delay further, but कुछ important चीजें बताना जरूरी है session के starting में ही. One more important thing is last year also, okay, I took a GTQ session, GATE through question session. It is available on Made Easy YouTube channel itself. Last year also I took the session. In that session, variety of numericals have been discussed last year. Okay, and this year certain new numericals I am going to discuss in this GTQ course. So what I recommend you guys is that last year GTQ, I think it's a 2-hour video, last year GTQ, उसका जो लिंक है बेटा वो मैं चैट बॉक्स में स्टाफ के थ्रू आई विल बी पुटिंग द लिंक ऑफ द लास्ट ईयर GTQ, so you can get the certain set of numericals. गेटिंग माई पॉइंट? तो आपके पास एक अच्छा बंच ऑफ न्यूमेरिकल्स हो जाएंगे. लास्ट ईयर का GTQ, इस साल का GTQ, नए न्यूमेरिकल्स हैं सारे के सारे. सो व्हाट यू आर गोइंग टू डू इज create a set of bunch so that you can utilize that set of bunch for your revision purpose and for other, or it is going to bring you a lot of confidence. So आखिर पिछले साल का भी GTQ आप देख सकते हैं और इस साल का तो है ही सब चीजें. चलिए, so without any further delay, yes beta, a lot of students are asking, will this video will remain on YouTube? Yes, it will remain public on YouTube. Okay dear, so don't worry about anything. You can access the video even after the session. Okay dear, don't worry about anything. Chaliye, let us start our wonderful journey today in fluid mechanics. Get set go, let us start. I am going to maintain a little bit fast pace. The reason being because I want to discuss maximum number of problems. Okay, so let us be very efficient today. So this is your first question that is there on the board. This is your first question that is there on the board. This is your first question that is there on the board. Read the question properly. I am giving you 30 seconds of time. Read the question properly, then we are going to solve the problem. A high pressure reactor contains a fluid at so the initial pressure is 5 atmospheric pressure in a container. If the pressure in the reactor increases to 30 atm, so you are changing the pressure in the reactor to 30 atm. Okay, the percentage reduction in volume, okay, with increase in pressure there is a reduction in volume of the reactor, and that is 0.18%. Estimate the bulk modulus. Wonderful. So my dear students, initial pressure is already given to you guys, but see the units is atmospheric, okay, and this is 5 atm. So what is the change in pressure? As such, change in pressure is 25 atm. How will you convert atm to pascal? So change in pressure is basically given to be as 25 atmosphere, and atmospheric pressure everybody knows is 101,325 pascal if you want it in pascal. So multiply this with so this is 25 into 101,325 pascal. So my dear students, you are going to get the value of delta pre from here. Calculations is your responsibility. I am going to give you the answers. Answers are there with me. I am going to give you the answers, but you should also cross check, cross verify all the answers. Okay, so the main thing is the concept today. And one more thing, the percentage decrease in volume is given. So how to write percentage decrease? So percentage decrease in anything is in volume is going to be change in volume by original volume. Why I have put a negative sign here? Because it is percentage decrease. So that's why with a minus sign multiplied by 100, because it is percentage. So that is 0.18. We have started with a simple numerical. Slowly and steadily the beautiful numericals are going to come. So let us go. So this is given. So my dear students, from here everybody know we want to find the value of bulk modulus. Bulk modulus is hydrostatic stress by volumetric strain. In fluid mechanics, hydrostatic stress can be written as change in pressure. Hope you guys remember, change in pressure divided by volumetric strain is minus of dV by V. Why minus sign? Yes. So therefore, hydrostatic stress by volumetric strain. Hydrostatic stress is 25 into 101,325 divided by dV by V with a negative sign will be 0.18 divided by 100. Clear guys? So from here you are going to get your bulk modulus. Come on. I am waiting for your answers in the comment box. Yes, very good. Very good. Anupam, Rahul, Rimu, Subrata. Wonderful dear. So your answer is going to come out to be 1.407 into 10 to the power 6 kilopascal. You should also cross check the answers. But one more thing is asked in the problem. The problem is not over. It is coefficient of compressibility. So he is asking you the compressibility also. So compressibility, which is beta, is actually defined as the reciprocal of bulk modulus of elasticity. Already bulk modulus of elasticity is known. You put it here, do the reciprocal, you are going to get the answer as 7.106 into 10 to the power minus 7 meter square per kilonewton, and this is going to be your answer. Clear guys? One more thing I want to tell you about today's session is, this question is okay, But I am a very strong believer that if you solve a good conventional problem, then already 2-3 concepts are covered in the same single conventional problems. I'm a very strong believer in that. So a lot of large problems are also going to come that is going to cater to 2-3 problems in GATE examination. Beautiful. Chalo. So I hope you got the correct answer. These are your answers. Let us move on to the next problem. I'm giving you 30 seconds of time. Read the question properly. I'm giving you 30 seconds of time. Read the problem carefully. Come on guys, come on. Yes, in an experiment, the tip of the glass tube with an internal diameter of 2 mm. So there is a glass tube having an internal diameter of 2 mm is immersed to a depth of 1.50 centimeter in a liquid of specific gravity 0.85. Air is forced into, this is known as air bubble test. I have seen this test in real life. This is known as air bubble test. Okay. So tube is of a spherical bubble is formed in at the end of the tube. The surface tension of you need to find for the liquid if the internal pressure inside the bubble is 200 Newton per meter square. My dear students, very important. Just see. So there is this glass tube is there. So this white color thing is the glass tube. I have already made the diagram so that we can save times and we can discuss a lot of numericals in a stipulated time. Okay dear. So this is our glass tube is there and this is inserted to a depth of 1.50 centimeter in a fluid of density 850 and air is forced into it. Air is forced into it. So what is forced into it? Air is forced into it and due to forcing of air a bubble is formed at the end of the tip. A bubble is formed at the end of the pipe. The important point to notice here is that it is actually bubble. It is actually bubble. A bubble is something you would have studied in the classroom. Its two surfaces are in contact with air. But my dear students, the point to remember is this is a bubble which is actually submerged in some liquid. So this is a bubble which is submerged in some liquid. So this is not a two interface system. It is a single interface system because only one of the sides is in contact with the air. The outer side is not in contact with the air. Clear guys? So let us use the Young's Laplace equation already derived in every batch of Made Easy. Every batch of Made Easy I have derived the Young's Laplace equation that the pressure on the pressure discontinuity at any interface is Pi minus Po sigma times 1 by R1 plus 1 by R2 and from here we get the result that pressure is always greater on the concave side in comparison to the convex side of the interface. But this is for a single interface system, this is for a double interface system. Now the problem with students is student will say sir bubble is a, by just reading the word bubble they will say sir it is a two interface system. No re baba, this is submerged in some fluid. So that's why it's a single interface system. For a bubble R1 and R2 will be taken equal to R. So therefore this is going to be 2 sigma by R which will be 4 sigma by D. So therefore for a bubble submerged in liquid, the pressure inside the bubble and outside the bubble across the curved interface, you see this is our curved interface, no, across the curved interface is actually 4 sigma by D, is actually 4 sigma by D for bubble submerged in fluid. Okay, so therefore Pi, what is the internal pressure inside the bubble? Inside the bubble the pressure is given in the question as 200 Pascal. Okay, wonderful. So this is given to be as 200 minus what is the outside pressure beta? Outside pressure will be due to this fluid which is outside it, which is rho GH. So this is going to be rho is how much? 850 into G into height is 1.50 centimeter. So therefore this is going to be rho is given to be as 850. Okay, wonderful. 850 into 9.81 into H, height is given to be as 1.50 centimeter which will be 1.50 into 10 to the power minus 2. Excellent. So this is Pi minus Po is equal to 4 sigma divided by diameter. We have to assume here that the diameter of the bubble is equal to the diameter of the tube. Okay, so that is 2 mm. So that is 2 into 10 to the power minus 3. So from here we can calculate the value of sigma and that will come out to be 0.0374 Newton per meter and that's your answer. How many of you got the answer? How many of you got the answer? Okay, wonderful. Oh, a lot of you have got the answer. Wonderful, yaar. Excellent. Chalo, this is the next question. Come on guys, come on. Read the question carefully. This is the next question. A cylindrical body, so there is a cylindrical body having 90 mm in diameter, 90 mm diameter and 500 mm long, of weight 15 Newton. So the weight slides vertically down in a 92 mm cylindrical sleeve due to its own weight. Oh my god, wonderful. The space between the body and the sleeve is filled with oil. Determine the so you need to find out the dynamic viscosity of the oil needed to restrict the velocity of the fall at 5 centimeter per second. This velocity can also be termed as the terminal velocity. Okay, so this is your diagram. Already I have made the diagram. Come on guys, I want your answers in the comment box. Be highly energetic during my session. Be highly energetic. Come on. So therefore, this is the outer cylindrical thing is there. This is the inner cylindrical shaft is there. The diameters are given already, and yes, the weight of this cylindrical inner cylindrical thing is 15 Newton, and you know this has to fall down at a constant speed. So you know when this the cylindrical shaft is something like this. Cylindrical shaft is something like this inside, and it is surrounded by some liquid. Some oil is there. Okay, so when this cylindrical shaft is going to move down something like this due to its own weight, there is going to be shear acting over the surface of the cylinder, and the shear is going to act in upward direction. Getting my point, bacho? So therefore you know how to balance it. The weight of this thing, is going to be in downward, and this will be balanced by the shear force. This is going to be balanced by the shear force in upward direction. Clear guys? Now just balances. So how to find out the shear force over the shaft? See, this is a linear motion of the shaft is there. I will tell you what I am talking about, because that is also very important for GATE examination. So therefore the weight of this thing is equal to shear force. Okay dear, so weight is how much? Is equal to 15, is equal to shear force. How to find out the value of shear force, bacha? The shear force is going to be shear stress multiplied by area. Shear stress will be written as mu into du by dy, multiplied by area, circumferential area, of course, because over the surface of this shaft it is going to act. So therefore it is going to be 15 is equal to mu. Viscosity is already given, values you guys can put. Du, clearly it is mentioned that the velocity distribution in this clearance zone is, what will be the value of clearance? This is very important. What will be this height? This height is point to be noted here, because maximum students what they are going to do is, this height is do minus di. No, it is going to be do minus di by 2 is the clearance. Come on guys, so that is 92 minus 90 by 2, that is 1 mm. Okay dear, change in velocity. So change in velocity is going to be, so what is the velocity here? Velocity here of the shaft is 5 centimeter per second. So that is 0.05 in minus 0, change in velocity. Here the velocity is 5 centimeter per second. Here the velocity is 0, divided by change in height is this clearance, and clearance is 1 mm. So that is 1 into 10 to the power minus 3. Excellent bacho. Multiplied by the area. Now area is going to be the circumferential area, and circumferential area is going to be 2 pi r of the inner shaft, okay, multiplied by the length. Every single thing is given to you in the problem. Or simply this 2 into r can also be written as pi dl. This 2 into r can also be written as pi dl, so that is your circumferential area, that is pi dl. Put each and every value in this and you are going to get your answer. Clear guys? Yes, wonderful. So my dear students, when you are going to calculate from here, I hope you would have got your answer. The value of viscosity will come out to be 2.12 Newton second per meter square. These variety of questions are quite important for GATE examination. I would say very important for GATE examination. Okay, but let me discuss a few things if I have got a chance here. Look here on the board, my dear students. For example, this is some stationary body is there, and this is some moving plate is there. So the shear force is given to be as mu AV by Y, is given to be as mu AV by Y, if you want to find the shear force here. Now these I am telling you, because I am making you revise here, that what variety of questions you have to focus, because I don't have the time to discuss each and everything. There is this inclined plane is there at an angle of theta, separated by a thin film of liquid. Separated by a thin film of liquid. These variety of questions again depends on this formula, but here F value will depend on the weight of this. I hope you guys have solved this in the classroom of Made Easy. These type of questions are also there in your workbook, beta. Now next type of question that are very important for your GATE examination, journal bearing. Come on guys, come on, I am making you revise. Just look at the board, just look at the board. Journal bearing, this is the outer cylindrical shaft is there. This is, I am making some rough diagrams. This is the outer cylindrical shaft is there, and there is this inner cylindrical shaft is there. There is this inner cylindrical shaft is there. But instead of moving down, doing a linear motion, this inner cylindrical shaft is rotating at an angular velocity of omega. Then in the problem he is going to ask you, find the torque, find the torque. So how to find the torque here? Torque is going to be F cross R. F is going to be mu AV, but it is rotational motion. So rotation mu AV, V will be written as R omega divided by this clearance, which is, let us say, H, multiplied by H into R. Here the area will be written as what? 2 pi R into L, the length of the shaft. I hope these kind of questions you guys have solved. Journal bearing, journal bearing. Look here, look here. Similar variety of questions can be asked like a footstep bearing. Beta, these are very important things for GATE examination. Remember, my dear students, remember, many times in paper, footstep bearing, footstep bearing, footstep bearing. So it is something like this. This is some, already these things have been covered in the classroom. I'm just making you revise. I'm just making you revise. This is the shaft is there, and this time the oil is, lubricating oil is below here, the shaft is below here, the shaft, and again the shaft is rotating. Again the shaft is rotating at an angular velocity of omega. Then again he is going to ask you the torque. Again he is asking you the torque. But this is not simple, because here you need to integrate to find out the value of torque. Here you need to integrate to find out the value of torque, because you know the lower part of this is going to be circular at a radius of r, and the value of velocity, because everybody knows for rotational v is equal to r omega. So radius changes, the velocity changes, shear force changes, so the torque changes. Torque changes. These are very important questions. Kindly. So therefore what you will do is, you will take a very small ring. For this small ring you will find small torque. Small torque will be small force multiplied by radius. Small force will be mu into dA. Very important, you guys know the drill. So these are very important topics that all of you need to cover. Again and again a lot of students are asking, sir, is this applicable for civil engineering also? Arey Baba, how many times I have to tell you, civil and mechanical engineering 99% course is almost, I will say, is exactly the same. So the GTQ which I am discussing here is common to both civil and mechanical engineering students. So kindly look into that. This is the next question. Come on guys, I am waiting for your answer. Yes, very good Manish, very good. Footstep bearing में integration होगा, बिल्कुल सही कह रहे हो, बिल्कुल सही कह रहे हो. बिल्कुल footstep bearing में integration होगा, ठीक है, याद रखना, ये सब important चीजें हैं. Yes, so this is the diagram. This is the diagram, my dear students. Let me explain to you the question. This is a fluid interface question, has been asked in the GATE paper of mechanical paper. See, remember, let me tell you guys one thing. If in a certain year, if there is a very important question which has been asked in the GATE paper of civil engineering, the chances of that question coming in mechanical paper becomes very high. And if a very good question has come in mechanical fluid mechanics paper, the chances of it coming into civil engineering is very, very high. Okay, so it happens like that. So let me explain you the question. This is the upper plate is there, and this is the lower stationary plate is there. But you just look at the beauty of the question, that in between there is no single fluid, otherwise directly F is equal to mu AV by Y. But there is no single fluid is there, there are multiple fluids are there in between, and this is known as, and this is the upper fluid, so this is fluid 1, this is fluid 1, and this is fluid 2, my dear students. Okay, so multiple fluids are there, viscosities are already given to you, the heights are already given to you. Now let me, he is saying the top plate is moving with a speed of 1 meter per second, the lower plate is of course stationary, the lower plate is of course stationary, and that fellow is asking you two things in the problem. He is asking you what is the force required to pull the upper plate at a speed of 1 meter per second, and second thing he is asking is what is the velocity of the interface, what is the velocity of the interface. Excellent. Again this F is equal to mu AV by Y that you have written, this is applicable, Baba, only when the things are having a linear profile. When the things are having a linear profile, then these things are applicable. So again, this is a linear variation, and if you remember from our classroom, the shear stress distribution in between a stationary and moving thing, the shear stress distribution is always one order less than the velocity distribution. If your velocity distribution is having a power of 2, okay, parabolic velocity distribution, then the shear stress distribution is going to be one order less than that. So the shear stress distribution will be linear. But in this particular problem, the velocity distribution is linear. Okay, it is linear. So linear means power 1. So the shear stress distribution is going to be constant. It is going to be constant. Excellent, bachu. So what is the fluid-fluid interface condition? Already taught in every batch of made easy. You know, this is the interface is there. So the shear acting throughout is the same. So tau 1 for this fluid at the interface and tau 2 for this fluid at the interface is going to be the same. So let us write the value of tau 1. Let us write the value of tau 1. So this is actually tau 2, and this is tau 1 I have taken. So therefore let us write the value of tau 1. Now tau 1 will be what? Tau 1 will be mu 1 into du by dy for the first fluid. For the first fluid, okay. In the classroom beautifully I have explained why the shear is same, why the shear at the interface is the same, okay. And this is mu 2 at this as this is not a concept class, okay, this is gate through questions class, so I will focus on the question. Mu 2 into du by dy for which fluid? Second fluid. Chalo, let us put all the values. So therefore mu 1 everybody knows how to write mu 1 is given in the problem. Du, my dear students, this is your first fluid. Acha, so here mu 1 is this. Oh, don't worry, let us take because according to the diagram के हिसाब से change कर लेते हैं यार, ताकि कोई confusion ना हो, ठीक है? You guys should not be in any type of confusion. Okay, look here. So this is fluid 1 and this is fluid 2. Okay, so for fluid 1, change in velocity. So for fluid 1, what will be the change in velocity? Change in velocity is actually velocity of the interface. Let the velocity of the interface is v1 and velocity of the top plate is v. So this is v1 minus 0 is the change, because interface velocity is v1 minus 0, okay, divided by dy. What is the change in height? 0.5 mm, which will be 0.5 into 10 to the power minus 3. Clear guys? Is equal to mu 2. Mu 2 everybody knows the value, calculation is your responsibility. What is the change in velocity for second fluid? Change in velocity for second fluid is v minus v1, but the value of v is given in the question as 1 minus v1, okay, divided by dy for the second fluid is 0.3. So that is going to be 0.3 into 10 to the power minus 3, because it is in mm. Clear guys? Equate both the things, everything is known to you. Can you find the value of v1 or the velocity of the interface? Yes, you can do so. Anyone with the answer? Come on guys, anyone with the answer? Anyone with the answer? I'm waiting for your answers. Yes, A lot of students are giving the answer 0.714. I'm very happy here. Meter per second. 0.714 meter per second is your answer, is the velocity. But still the question is not over. What else you need to find out? You need to find out the force that is required over the top plate. So you know the shear throughout is the constant. So therefore tau 1 equal to tau 2 is also equal to tau over the plate. And tau over the plate can be written as force divided by area of the plate. Area of the plate is given to be as 1. Clear guys? So therefore equate this to this, you will get the value of force. You guys can easily solve. I am writing the force on the board. It will come out to be 142.8 Newton. Wonderful. So that's your answer. Areva, Surya, Subrata Das. Come on guys, come on. Surya, Subrato. Very good yaar. Correct answer. Correct answer. Bilkul. Till the time I am drinking some water, kindly read the next question. Come on guys. Very good. As shown in the figure, the pipe M contains carbon tetrachloride of specific gravity itna, okay, under a pressure. So the pressure of that is also given, and there is a pipe N which contains a oil of specific gravity 0.8 having a pressure of itna. Just look at the units, kgf per centimeter square. I hope you guys know how to convert. So 1 kgf per centimeter square. My dear students, I am telling you, it happens in GATE examination, because generally it is seen in GATE examination that the question will be given in some other units, okay, and the answer will be given in standard unit. So you need to convert. I have to move in a fast manner because I told you guys that yes, I need to cover a lot of things, 1 into 9, but it will give you a holistic view, my dear students. Centimeter square to meter square is 10 to the power minus 4 in the denominator. That will move up to 10 to the power 4. So this is the conversion factor. Okay dear? Chalo. So this is the diagram which is given. Simple. Let us apply the jumping jack method. Or if you are comfortable with the datum technique, you can use the datum technique also, doesn't matter to me. So this is your jumping jack method I am talking about. So for the jumping jack method, let us start from here, bacha. Everybody should be knowing PM. So what is the pressure here? PM. But let us convert 1.05 into, just now I told you, PM pressure is 1.05 kgf per centimeter square. So how to convert 1.05 into 9.81? Come on guys, those of you who are confident, come on. So 1.05 into 9.81 into your 10 to the power 4. Wonderful. So here you have written this pressure. Now you are moving vertically down up to this point. Okay, which fluid is this? It is having a specific gravity of 1.594. So density is going to be 1594. Okay dear? So vertically down will be plus rho GH. So rho is going to be 1594 into G is 9.81 into height. How much is the height? 2.5 plus 1.5. So 2.5 plus 1.5 is going to be 4. Wonderful. Now my dear students, you guys have reached up to this point, okay, but you need to come at this certain level. So you again are moving vertically down. So that is mercury. So in mercury you are coming vertically down. So again plus, downwards is positive pressure. Okay. So this is plus rho GH of mercury, that is 13.6 into 10 to the power 3 into 9.81 into height. How much is the height? You need to find out this value x. Arey Baba, this is asked in the question yaar, that what is this deflection x? Okay. Now next important thing, see, everybody knows that this is jumping jack method. The pressure at this particular point is same as the pressure at this point. So you can directly jump from here to here, because if you move vertically down from here and then come in again from here, that will get cancelled out. So no need to do that calculation. Is equal to, you have jumped up to this point. Still our calculation is not over. From here we are moving vertically up. So from here we are moving vertically up. So if we are moving vertically up, my dear students, vertically up will be minus. Which fluid is this? Oil having a specific gravity of 0.8. So this is going to be 800 into 9.81 into height. How much is the height, beta? Yeah, see this much of height, 1.5 plus x. So this is 1.5 plus x. Excellent bachcho. Is equal to pressure in N, which is 1.75 into 9.81 into 10 to the power 4. So from here, if you do all the calculations, you will find the value of x, and this is going to come out to be 14.25 centimeter. You can check. Come on guys, come on. Yes, very good. Very good. A lot of you are giving the correct answer. Sachin Sharma, wonderful dear, wonderful. Chalo, let us move on to the next problem. This is a good one. The compartments B and C shown in the figure are filled with air. The barometer reads. Barometer is a device that is used to measure the atmospheric pressure. Okay dear, reads itna 99.572 kilopascal. When the gauges A and D read as indicated, what should be the value of x? What should be the value of x for gauge E if mercury is the manometer in the U-tube? So this is your diagram. This is your diagram. Come on guys. This is your diagram. Come on guys. Come on. I'm giving you 30 seconds of time. Just look at the problem. Just look at the, you need to find out the value of this x. You need to find out the value of this x. Okay. Now, chalo, let us start. See, this is chamber C. This is chamber B. Okay. Air is filled in this. Air is filled in this. So whatever is the pressure of the air in chamber C, that pressure is actually going to apply over this point, which is PC. That is going to apply over this point PC. So first of all, let us talk about this manometer. And let us do all our calculation in terms of gauge. Why I am doing all my calculations in terms of gauge? Acha, do you know, when I do all my calculations in terms of gauge, I take the atmospheric pressure to be as 0, the golden rule, okay? Because for this container, the pressure is given by this gauge device, okay? So this is gauge pressure of A. So here gauge pressure is given. So let us do all our calculations in terms of gauge, okay dear? So let us apply here. So here the pressure is PC. Now from here to here you are going to move vertically down, and this fluid is mercury. So PC vertically down will be plus rho GH. Rho GH is going to be how much, beta? Mercury. So it is 13.6 into 10 to the power 3 into 9.81 into height. How much is the height? 0.25 meter. 0.25 meter. So this is 0.25. Okay. Now once you have reached up to this point, now you jump from here to here because the pressure is the same, and the pressure here is atmospheric pressure, and we are doing our calculation in terms of gauge. So we are going to equate it to 0 because we are doing it in terms of gauge. So what is the value of PC gauge pressure of this chamber C? When you are going to calculate this, this is going to come out to be minus 33.354 kilopascal. Wonderful. Now once the pressure of this chamber is known, let us again apply manometry over this manometer. So let the pressure of this chamber is some PB, gauge pressure. Gauge pressure, we are doing all our calculation in terms of gauge, and gauge pressure of this chamber is already measured by this device, which is 2.1 into 10 to the power of this. So therefore here, my dear students, look at the board. Here what is the pressure? Here the pressure is 2.1 into 10 to the power 5 gauge. Okay, so 2.1 into 10 to the power 5. Now you jump from here to here, jumping jack, and you move vertically up from here. So vertically up from there is minus, it is mercury. So 13.6 into 10 to the power 3 into 9.81 into height is x is equal to what is the pressure at this point? The pressure at this point is PC. And we are doing it in terms of gauge. Already gauge pressure of this is known. So minus 33.354 33.354 kilopascal, but it is in kilopascal and this is in pascal. Units are very, very important in GATE examination. So convert it into pascal, multiply it with 10 to the power 3. So from here, my dear students, when you are going to calculate this stuff, you are going to get the value of x. You are going to get the value of x as 1.824 meter. Anyone with the answer? Any? अरे वाह, wonderful यार, wonderful बच्चों, क्या बात है. देखो, my mode of language will be English of course, because I have to cater to South Indian students also. Okay, so this is going to be your answer. Excellent. Again I am saying that last year I also took a GTQ. It is there on Made Easy YouTube channel. After today's GTQ, you also watch that video. You will get new questions. You will have a bunch of beautiful numericals. Come on guys, read the question properly. What is the intensity of pressure in an ocean at a depth of 1500 meter? So there are two parts are there. Okay, first part is very simple. Salt water is incompressible. So let me solve the first part here itself. So the pressure in an incompressible fluid is given to be as rho gh. Pressure in an incompressible fluid is given to be as rho gh. Rho into g. See, specific weight of sea water is given as 1. So rho into g. My dear students, specific weight I show by symbol g. W. Specific weight I show by symbol W. Some of the books they show the specific weight by symbol gamma. Doesn't matter, it's just a denomination. Either you show with W or either you show with gamma. It doesn't matter, bachche. Okay, so therefore rho gh, rho into g is specific weight, which is 10050 into height. How much is at how much depth? 1500 meter. So you will get your answer from here. This is very simple, but the second part is beautiful. My dear students, how to do it? Salt water is this is a very interesting part. It is compressible, and you know this formula P is equal to rho gh. If you remember our classroom discussions, this P is equal to rho gh is only and only applicable to incompressible fluids, not to compressible fluids. But yes, dP by dH, which is hydrostatic law, dP by dH, which is equal to rho g, the hydrostatic law. This is valid to compressible as well as incompressible fluid. बच्चों कुछ ध्यान आ रहा है क्लास का? सब कराया हुआ है. Okay, but P is equal to rho gh is not applicable to compressible fluids. Okay, and W is itna and this is itna. Bulk modulus is given to be as a constant. He has to give because the density will change. Now see, look here on the board. So there is this sea water is there. I will give you hint to this question. Calculations you have to do. Okay dear. So there is the sea water is there. You need to find at a depth of A, which is 1500 meter from the top. Let the density at the surface is rho naught and let the density at some point A is rho. Okay, because the density will change. Now it's a compressible fluid. Compressible means density changing, but the bulk modulus remains constant and specific weight at the surface, which density is rho naught into g, is given in the problem. Now how to solve this particular problem? Let me give you some hint. See, whether it is compressible or incompressible doesn't matter to me. dP by dH will be equal to rho g. dP by dH will be equal to rho g, है ना? So from here dP can be written as rho g dH. Let it be like that. But one important thing given in the question is, beta, now some complicated problems are coming on the board. Be highly attentive. You will get to learn a lot of things. So yes, what is the formula for K? Formula for K is dP divided by volumetric strain, that is minus of dV by V. But minus of dV by V, from, if you remember our classroom discussion, it can also be written as this d rho by rho. So bulk modulus can also be written as rho into dP by d rho. So from here you can find the value of dP. So dP can be written as K into d rho by rho. So what you do is you replace this value of dP into this. So this is going to be K into d rho by rho is equal to rho g dh. Okay dear, so from here let us find the value of dh. So dh can be written as k by g, into d rho by rho square, can be written as d rho by rho square. Now let us integrate. When the height is changing from 0 to h, here the height is 0, here the height is h, which is actually 1500 meter. So height is changing from 0 to h. K is a constant, so can be taken out of the integral. G is a constant, can be taken out of the integral. Only integration will happen to the density, because the density is going to change. So when the height is 0, the density is rho naught, and when the height is h, the density is rho. So my dear students, the integration of this will come out to be h, is equal to k by g, and this will be rho to the power minus 2, integration will be rho to the power minus 2 plus 1 divided by minus 2 plus 1, so minus you are going to take outside, and that will be 1 by rho, and 1 by rho, when you put the limit, it will be 1 by rho minus 1 by rho naught, so this can be written as h is equal to, see, when you take minus sign inside, this will reverse out, this can be written as 1 by rho naught g minus 1 by rho g, clear guys? It's a beautiful problem, just look at the board. So from here you can write h by k is equal to 1 by rho naught g minus 1 by rho g. Can anybody tell me what is this rho naught g? This is the specific weight at the surface. Which is given. So h value is given to be as 1500 meter divided by k. Bulk modulus is 2070 mega newtons. 2070 into 10 to the power 6 is equal to 1 by rho naught g. Rho naught g is specific weight at the surface, 10050 minus 1 by rho g. Okay dear, so from here can you find the value of rho? Yes. See, I am now giving you hint. Already the मुश्किल वाला हिस्सा मैंने सॉल्व कर दिया है. मैं अब आपको हिंट दे रहा हूं कि आगे कैसे अप्रोच करना है इस क्वेश्चन में. जब रो आपको मिल जाएगा, मतलब 1500 मीटर नीचे की गहराई पर अगर आपको डेंसिटी मिल जाएगी, अब तो खेल आसान है, हमें प्रेशर निकालना है. तो लेट अस यूज दिस. सो हमारे पास ये है dp इज इक्वल टू k d रो बाय रो. इंटीग्रेट करो, ठीक है. इंटीग्रेट अगेन. So when you are going to integrate this, you are going to get the pressure at depth, and the 1 by rho integration will be log, and limit will be from rho naught to rho. Okay, and this will be, pressure will be from 0 to p in terms of gauge pressure. Okay, that's why you are taking the pressure at the surface to be 0 na. So this is going to come out to be yes, let me tell you the answer. When you are going to calculate this, rho by rho naught is going to become after integration, because you are going to integrate from rho naught to rho, and this from 0 to p. So when you are going to integrate this, all the rho value you have already find it out, put the value of k, the pressure at depth will come out to be 15.1392 mega Newton per meter square, and that's your answer. It's a fantastic problem. Arey वाह यार, many students have done the correct answer. Harish, Anupam, Rahul, Ashirbad, Subrata, Souvik, Atul, very happy यार, very happy. आप अगर ये क्वेश्चन उड़ा दिए तो मजा आ गया भाई पेपर में. आ जाओ, आगे बढ़ते हैं. हाँ चलो, read this problem. Come on guys, come on guys, come on. I'm telling you now, I have bought some excellent variety of questions with you guys. But देखो, कुछ भी करने के लिए ना पहले क्लास की चीज रिवाइज का, आपका तैयारी पूरा होना चाहिए, तब तुम एंजॉय कर पाओगे कि अभी सर की फ्रीक्वेंसी से मैच कर रही है मेरी फ्रीक्वेंसी. आपकी और मेरी फ्रीक्वेंसी तभी मैच कर पाएगी जब आप वेल प्रिपेयर्ड हो सब्जेक्ट में. अदरवाइज तो बड़ी दिक्कत है बच्चे. बड़ी दिक्कत है. A gate of size इतना can slide in an airtight friction held in place with a thin cable with a balloon having a diameter d, negligible weight, the gate just opens the level of the water as shown. Where should the cable be attached? Where should the, so you have to find the location where the cable is attached. Okay, see, let me make you understand in the problem itself. Again, it's a beautiful problem. Again, it's a beautiful problem. Come on guys, look here on the board. Again, it's a beautiful problem. So this is the rectangular gate is there, which is fixed in a channel, and here water is there. Water is there. So try and understand. So this is our rectangular gate. Let me make the 3D cross section of this. If yes, so it is going to be something like this. So this side is 2 meter of this rectangular gate, and the depth of the rectangular gate is 1 meter. 2 cross 1 is the size of this gate. Now you know water is there on this side, and this is connected with the help of a string. So this is the string. It's a mind-boggling problem, yaar. It's a string, and that string is connected to a balloon whose diameter is given as d. Now that, first of all, try to understand what is going to happen in the problem. For this rectangular gate, water is on this side, so that water is going to apply hydrostatic force over this gate. Due to that, of course, that hydrostatic force will not act at the center of the gate. रे बाबा, कैसा बात करता जी तू? सेंटर ऑफ द गेट पे मेरे बच्चे, सेंटर ऑफ द गेट पे एक्ट नहीं करेगा, सेंटर ऑफ प्रेशर पे एक्ट करेगा. और वर्टिकल गेट है ना, so you would have read in hydrostatic force that for vertical gate the center of pressure lies below the center of gravity, below the center of gravity, है ना. So therefore somewhere here is going to lie the point of application of the force, and due to that this gate is going to rotate. Force ऐसे लगेगा तो ये gate ऐसे rotate करेगा. समझ रहे हो आप बात को? लेकिन वो रोटेशन ना हो, that rotation should not take place. You are applying this string at a particular location at the gate. Of course, you need to apply this string at the center of pressure of the gate, and that force over this gate in this direction is balanced by the pull in the string due to the buoyancy force over the balloon. What a problem, yaar. What a problem. So you need to find out the diameter of the balloon. You need to find out the diameter of the balloon for equilibrium of the gate and also the location. चलो सबसे पहले यहाँ से शुरू करते हैं. What will be the hydrostatic force? Hydrostatic force is WAX bar. So W is 9810 multiplied by the area of the gate is 2 cross 1 into X bar. So my dear students, somewhere here is going to lie the CG. What is X bar? X bar is the vertical distance of CG of the gate from the free surface. Come on guys, come on, कैल्सी चलना चाहिए, हाथ चलना चाहिए. यहाँ नॉर्थ इंडिया में ठंड बहुत ज़्यादा है. It is really very chilled out here. But you know, ये conceptual गर्मी आज हम ले रहे हैं. मजा करो यार, आ जाओ. So gravity is here, and you know this distance is going to be X bar, because you need to take this distance from the free surface. So this is going to be 3 plus center is 1, so this is going to be 4. So from here, when you are going to calculate the force, let me give you the answer. When you are going to calculate the force, this will come out to be 78480 Newton. 78480 Newton. Wonderful. Then what else you need to find out? Point of application of the force will be given at, acha, some of the student will say, sir, I will find the force by pressure prism technique. It's your choice, completely your choice, बच्चा. वहाँ से भी निकाल लो, same answer आएगा, plus IG divided by AX bar. Why I am not taking sin square theta here? Why I am not taking sin square theta here? Because it's a vertical gate, sin 90 is 1, okay? So IG for this gate, what you will take IG for this gate? 1 into 2 ka cube divided by 12. Area you know, X bar you know. Can you find out the value of H? Yes, you can find out. And this is going to come out to be 4.0833 meter. And this is the value of H, where the hydrostatic force is going to act. Wonderful. Nice. Now, you see, this is going to be balanced by the tension in the string. So therefore, you know, the buoyancy force over this balloon is going to act in upward direction because it is completely submerged, and it is going to be balanced by the tension. So if you make the free body diagram of the balloon, then you are going to get tension is equal to the buoyancy force, and tension in the string is equal to the hydrostatic force. Come on guys, because whatever is the force of pulling here, na, that is balanced by this tension. Na. So tension is equal to your hydrostatic force. So tension already you know 78 78480 is equal to buoyancy force. Everybody knows rho of what? Rho into G into volume of the body submerged, but this sphere is completely submerged. So therefore, my dear students, what you're going to do here is rho of the fluid is water into G. So this is 9810 rho into G into volume. It's a sphere. It's a sphere. So 4 by 3 pi r cube. Okay, so from here convert the radius into diameter. Can you find the diameter? Yes. So diameter will come out to be 2.481 meter. 2.481 meter. And you know, where should this string be attached? This string should be attached as the center of pressure of this gate. So center of pressure of this gate lies at a distance of 4.0833 from the free surface. Arey Baba, this is the distance from the free surface now. So where should the string be attached? So total distance from the free surface is 4.0833 minus 3. So therefore string should be attached at a distance of 1. So this distance is 1.0833 meter from the top of the gate. Excellent student. Arey wah. Harsh, Neha, Shushil, Subrata, wonderful बच्चों. सचिन, सूर्या, विवेक, मजा आ गया यार, मजा आ गया. अगर ये कर दिए तो देखो कितना लॉजिकल और प्यारा क्वेश्चन है. लॉजिकल और प्यारा क्वेश्चन है. आ जाओ नेक्स्ट प्रॉब्लम. माइंड बॉगलिंग प्रॉब्लम. But in this problem, some of the civil engineering students might face some problem. Some of the civil engineering students might face some problem. Okay, but this, only for this problem. Okay, but it was a wonderful problem, so I have to take it. A cylindrical can open at one end is 20 centimeter in dia and 40 centimeter long. So it is 20 centimeter in dia and 40 centimeter long. The cane weight of the can is 6 Newton. Okay, the can is carefully put in a large tank vertically with its open end downward and air is trapped. Oh ho ho! This kind of things you do generally in real life also, yaar. These kind of things you generally do. In real life also. See, this is a can is there, cylindrical can only, this glass in my hand. I hope you are able to see. And what you are doing is you are inverting this glass and you are putting it into water. A container filled with water. Okay, so you are putting in it. Now what will happen is the air which is inside this container, na, and when you are going to put into that air is going to get compressed. And in the question he is saying that the air is going to get compressed isothermally. Isothermally. Wonderful problem, yaar. So you know, you have inverted the can. The length of the can is 40 centimeter, diameter is 20 centimeter, and air inside the tank is getting compressed. Okay, so here this is the level of the liquid outside the can, and there will be level of the liquid inside the can. Okay, so this is the can because air is entrapped in between. Air is entrapped in between. Okay, air is entrapped in between. So therefore inside the can water liquid level will be somewhere here, outside the can liquid level will be somewhere here. So that fellow is actually asking you, try to understand this beautiful problem here. That fellow is actually asking you to find out the difference in the level outside the can and inside the can. So he is actually asking you to find out the value of H, and also he is asking you to find out the value of L, that the distance between the top of the can and this liquid surface outside the can when the air is compressed. Chaliye, let us start. So you know, above the can the pressure is atmospheric pressure, and what is going to be the pressure here? What is going to be the pressure here? The pressure here is going to be some P, and that P is going to be PATM, because here also the pressure is atmospheric pressure. So that is PATM plus rho GH up to this point, plus rho GH up to this point. Not here. So the pressure at the bottom is, let us say, P, which is going to be PATM plus rho GH. That is going to be, it is water only, na? It is water or something else. Yes, it is put in yes, water tank. It is put in water tank. So this is going to be rho of water. Calculation you need to do G into H. Okay, dear. So you know the difference of this pressure is actually balancing the weight of the can. The difference in this pressure is going to balance the weight of the can ultimately. So therefore 6 Newton is the weight of the can, and that is balanced by the difference in the pressure, and difference in the pressure is going to be P minus P ATM. P minus P ATM. Okay, that's the pressure multiplied by the area of the can, which is pi by 4 into d square, which is 0.2 ka square. My dear students, P value already you know, so 6 Newton is equal to P ATM plus rho of water into G into H minus P ATM. Come on guys, solve with me. And this multiplied by the area of the can, which is pi by 4 into 0.2 ka square. So the P ATM is cancelled out. There is only one unknown in this problem, which is H. So when you are going to find out the value of H, my dear students, this will come out to be 1.95 centimeter. This will come out to be 1.95 centimeter. Excellent problem. Excellent problem. Very good. Now come on for the next part. If this is air inside and air is getting compressed isothermally, the air is getting compressed. For isothermal compression, everybody knows P1 V1 is equal to P2 V2 for air. Okay, so let us apply. What is the initial pressure of the air inside the can when it is not dipped into water? What is the initial pressure? Initial pressure is going to be P ATM. Initial pressure is going to of the air is going to be P ATM multiplied by the initial volume of air in the can will be equal to volume of the can, pi by 4 into d square. D square is 0.2 ka square multiplied by H multiplied by total height of the can is 0.40. 0.40. Excellent bachcho. Is equal to P2 V2. What will be the final pressure? What will be the final pressure of the air inside the can? See, the air inside the can is actually balancing this pressure. Can you guys guess that? So the pressure, final pressure after compression of the air, the final pressure is going to be P. The final pressure is going to be P, है ना, multiplied by final volume. Final volume of the air in the can is this volume. Getting my point? That is going to be pi by 4 into d square. That is going to be pi by 4 into d square, that is 0.2 ka square multiplied by height. What is the height, bachcho? Height is L plus H. Height is L plus H. Everything is known to you guys. You guys can easily solve. The value of L will come out from here 37.97 centimeter, and that's your answer. That's your answer. Anyone with the answers? Anyone with the answer? Oh, wonderful यार. कुछ बच्चों ने सही आंसर दिया है. अनुपम, मेहरा, सुब्रता, excellent यार, excellent. चलो आगे बढ़ते हैं. Yes, again a good one. A rectangular body 5 meter long, 3 meter wide and 1.2 meter in height is immersed to a depth of 0.8 meter. Find the metacentric height. What is metacentric height, बच्चे? Metacentric height is GM. GM is basically BM minus BG. BG is the vertical distance between center of buoyancy and center of gravity. And BM is what is the formula for BM? BM is I by V, where I is the least moment, or in other words you can say rolling moment of inertia. Remember the class, rolling moment of inertia about surface formed at the free surface, and this is volume of the fluid displaced. Wonderful. So therefore what he is saying in the problem, let me make the diagram. He is saying that there is this rectangular block is there. There is this rectangular block is there, that is 5 meter long, 3 meter wide and 1.2 meter in height, is submerged in water up to a depth of 0.8 meter. देखो बच्चों, जो लोग क्वेश्चन को रीड नहीं कर पाए तो मेरे डायग्राम को फॉलो करो ना, आपको अपने आप क्वेश्चन समझ में आ जाएगा. मेरा बच्चा समझ नहीं रहा है तू बात को। अगर किसी को लग रहा है कि सर यू आर मूविंग टू फास्ट, तो बच्चे मुझे फास्ट मूव करना पड़ेगा बिकॉज आई वॉन्ट टू कवर हेल लॉट ऑफ थिंग्स फॉर यू। एट द एंड ऑफ द डे यू विल रियलाइज द एफिशिएंसी ऑफ दिस सेशन, you will realize the efficiency of this session, super session. But if you are not able to read the question properly, then follow the diagram here, automatically you will understand what is asked in the problem. But this is going to be submerged from all the sides, no? It's a 3D thing. So this is submergence 0.8 meter. Okay, he is asking for metacentric height. He is asking for metacentric height. How many of you are able to understand that this is the surface formed at the free surface? This green color which I am showing, this is the surface at the free surface. This is also known as waterline area. This is also known as waterline area. Chalo, let us start our problem. So I need to calculate GM. And of course we need to always calculate and give the answer as least moment, based on least moment of inertia, which is rolling and pitching. कुछ याद आ रहा है कक्षा में कराया गया है, is actually BM minus BG. First of all, let us calculate BG. It's a symmetric body, so the center of gravity of the body is going to lie exactly in the center, and that is going to lie at a distance of 0.6 meter from the bottom of the body or from the top of the body. What is the other thing you need to indicate? Buoyancy. Center of buoyancy lies at the centroid of the volume of the fluid displaced. So this 0.8 meter is the volume of the fluid displaced. Come on guys, which is again symmetric. So exactly in the center of the fluid displaced is going to lie the center of buoyancy, which is actually going to lie at a height of 0.4 meter from the bottom of the body. And ultimately you are going to get the value of BG from here. So value of BG is 0.6 minus 0.4. So value of BG is going to be 0.2. Now next is what? BM is I by V, which is the least moment of inertia of the surface formed at the free surface or the waterline area. Waterline area is a rectangle. For this rectangle the sides are 3 and 5. So there will be 2 moment of inertias for this rectangle. What are those 2 moment of inertias? 5 into 3 ka cube divided by 12 and 3 into 5 ka cube divided by 12. Clear guys? Wonderful. Which one will you take? You will take the least moment of inertia. You will take the least moment of inertia. So least moment of inertia out of these is going to be 5 into 3 ka cube by 12. So this is 5 into 3 ka cube divided by 12, which is the rolling moment of inertia, divided by volume of the fluid displaced is 0.8 into 5 into 3. So from here when you are going to calculate the value of BM, this will come out to be 0.9375 meter. Okay, so this is 0.9375 meter. So metacentric height will come out to be 0.7375 meter, and this is going to be your answer. This is going to be your answer. अरे वाह, दिल खुश कर दिया बच्चों, इतने सारे स्टूडेंट्स ने सही आंसर दिया है. श्रेया, अनमोल, मनीष, ऋषि, सुशील, अनुपम, वंडरफुल यार, वंडरफुल. This is rolling metacentric height. Okay, pitching will again of course will be greater than that. Find the resultant force on this sectorial gate. This is the diagram. The depth of this sectorial gate into the board is 1. The depth of this sectorial gate into the depth of this sectorial gate into the board is 1. Come on guys, find the resultant force. आज थकना नहीं है, हारना नहीं है, रुकना नहीं है, इधर से उधर कहीं मूव नहीं करना, कैल्सी चलते रहना चाहिए बस, कैल्सी चलते रहना चाहिए बस. कैल्सी चलते रहना चाहिए बस. अच्छा, few days back, I think 1.5 weeks back, I took, listen carefully, that is very very important again. I took a special session on Made Easy YouTube channel. You will find 1.5 weeks back, just you will find that video. I took a beautiful session on hydrostatic force curved surfaces. In that video, I have discussed beautiful questions. This is some cylinder is there, this is some surface is there, and some fluid is there. You need to find the force over the cylinder. This is some container is there, and this is some fluid is there. Find the resultant force over this cylinder. I have multiple fluids. Here some other fluid is there, here some other fluid is there. How to find out the force? If this is some cylinder is there and it is submerged in, let us say, multiple fluids, water and whatever, let us say mercury or something like that, find the resultant force over this cylinder. In that video, I have discussed curved surfaces in detail. Curved surfaces in detail. तो अगर कोई बच्चा करना चाहता है तो you can see from there. These are very important questions for your GATE examination, but I am not taking these questions here because you guys know that already if I have discussed something, then why to discuss again. Okay, तो वो जो कर्व सरफेस का भी वीडियो है उसका मैं लिंक कमेंट बॉक्स में डलवा दूंगा ताकि आपको इजीनेस रहे, ठीक है. डोंट वरी अबाउट एनीथिंग. चलो मैं इसका हिंट दूंगा, मैं पूरा सॉल्व नहीं करूंगा. आओ, इस सेक्टोरियल गेट पे हॉरिजॉन्टल और वर्टिकल फोर्स निकालना है आपको. सो इट इज अ कर्व सरफेस हैविंग अ डेप्थ समथिंग लाइक दैट. सो दिस इज द कर्व सरफेस. here there is water is there. So first of all, how to find horizontal force over the curved surface? This is going to be the vertical projection. I'm going to give you the hint only. Okay, this side is 1 meter, angle is 60 degree, so this will come out to be, I think, 0.5 meter if I am not wrong. Calculation is your responsibility. And from here, can you find the value of this h? Yes. Trigonometry or simple trigonometry, you can find the value of this h. So this height is going to be 2h and the depth is 1. So the horizontal force over this is going to be equal to Wx bar. Let me give you the answer. The horizontal force, this h value na, this will come out to be 0.866025. okay, so this horizontal force will come out to be 23.21 kilonewton. Come on guys, 23.21 kilonewton. Next important thing is what you need to find is the vertical force. Now everybody knows from our classroom courses that vertical force will be equal to the weight of the fluid contained by this curved surface here. Now how to find this volume? Because the weight of this fluid is going to be rho of the fluid into g into volume of the shaded portion. Now the problem is how to find out the volume of the shaded portion. It's not a circle, semicircle, no, it's a sector. So what you do is, first of all, you find the area of the complete sector. How to find area? I am giving you hint here because I hope you will be able to do this question. Okay, so I am giving the responsibility of this question to you guys. Area of sector. How to find area of the sector? Area of the sector is theta divided by 360 into pi r square. R value is 1. Okay dear, and theta value is how much? 60. Theta 60. Total sector angle is 120 degree. Total sector angle is going to be 120 degree. Okay dear, you can find area of the sector from here. Then from area of the sector, subtract the area of the triangle. Area of triangle is going to be half into base is, let us say, h into height is 0.5. Okay dear, when you subtract, you will get the area of the shaded portion. Area of the shaded portion you are going to get. I hope you will be able to solve this. Area of the shaded portion will come out to be 0.6140873. Multiply by this, you will get the vertical force. Okay, then you know when you are going to calculate this, vertical force will come out to be 6.024 kilonewton, and that's your answer. Very good. नहीं ऋषि, गलती नहीं करनी है. 60 degree is only half angle, so you should take the complete sector na. So that is 120 degree. Come on guys, buck up. Beautiful questions are coming on board, but remember These variety of questions I am not taking in GTQ because I would have solved one question like this, because these are very important for GATE examination and I expect something new and different. देखो बच्चों, मेडिजी के क्लासरूम में ना जाने कितने क्वेश्चंस करवाए गए, लेकिन यार कुछ अलग डिफरेंट आएगा तो आपको सीखने को मिलेगा ना, सीखने को मिलेगा चीजों को. So these are very important thing. I will pin up the link to this in the comment section. Wonderful. Oh, this is again a fantastic problem. One of my favorite problems. Come on guys, read this problem. Read this problem. A 10 centimeter diameter orifice discharges water at 45 liter per second. I just love this question. I actually just love this question. Read this problem here. Read this problem. Very good. Very good. Thanks Anmol. Oh my God. Manish. Anmol. Wonderful yaar. Arey enjoy karo yaar. Just look at the efficiency of the session. हमें सिर्फ पढ़ाई दिखावे के लिए नहीं करनी है, हमें पढ़ाई असलियत में पढ़ने के लिए करनी है. एंड वी पीपल आर मैकेनिकल सिविल इंजीनियर्स. हम लोग एफिशिएंसी हाई नहीं रखेंगे चीजों समय के साथ. नॉट इवन अ सिंगल सेकेंड शुड गो इन वेस्ट. पढ़ो पढ़ो पढ़ो. A flat plate is held normal to the jet just downstream from the vena contracta, requires a force of 310 Newton, impact of the. Find the CC, CV and CD. Fantastic question. This is the diagram. So there, let me explain you the question. This is a tank is there and there is an orifice in the side of the tank. The diameter of the orifice is given in the problem as 10 centimeter and the discharge of the liquid coming out of the tank is given to be as 45 liter per second. Is given to be as 45 liter per second. Wonderful. What else is given in the problem? The head in the tank is given to be as 2.75 meter. Okay. And water, see this is the plate. So water jet which is coming out of this orifice is hitting this plate. Now to resist the motion of this plate, you are applying a resisting force of 310 Newton from this side. You are applying a resisting force of, yes, 310 Newton from the other side. You need to find out the value of coefficient CD, CC and CV. See, first of all my dear, this discharge which is given in the question, अरे सुन लो भाई, सुन लो मेरी बात. Discharge जो कि दे रखा है, this is a real thing, मतलब it is coming from experimental that you have measured. So this is actually actual discharge. This is actual discharge. This is actual discharge. Okay, so let us find the theoretical discharge. So theoretical discharge is going to be area theoretical of the orifice multiplied by theoretical velocity. Multiplied by theoretical velocity. Achha, how to find out the theoretical velocity are very simple. If you remember the classroom, very simply the theoretical velocity is going to be under root of 2gh. Theoretical velocity is going to be under root of 2gh. Wonderful. Use the Bernoulli's equation yaar. Apply Bernoulli's equation between 1 and 2. Apply Bernoulli's equation between 1 and 2. You will get the velocity of discharging out. As it is a large reservoir of tank, the pressure at 1, the velocity at 1 is going to be 0 because we are solving in terms of gauge, and P2 also is going to be 0 because atmospheric. And yes, you are going to get this theoretical velocity is under root of 2gh. So therefore theoretical discharge is going to be area theoretical. Area theoretical is going to be pi by 4. It's a brilliant problem yaar. 0.10 ka square into theoretical velocity is under root of 2gh. H is 2.75 meter. 2.75 meter. You will get the theoretical velocity from here. Okay. Once you get the theoretical velocity, can you find the value of CD? CD is going to be Q actual by Q theoretical. Q actual is already given to you 45 into 10 to the power minus 3 divided by, when you are going to calculate the theoretical discharge, this will come out to be 0.05769 something you are going to get, and the value of CD will come out to be 0.780. Fantastic question here. 0.780. Clear guys? CD is known. Next look here. Let us take a control volume here. Let us use the momentum equation or the Newton second law here. rate of change of momentum is equal to force. Rate of change of momentum is equal to force. So m dot in into the control volume minus m dot out of the control volume, rate of change of momentum, okay, will be equal to the force over the plate. And everybody knows that is going to be rho a v square. Simple. You hydraulic machines में भी यार impact of jets में हम लोग देख चुके हैं ये सब. Let us not waste time. So the force of impact by the jet is going to be equal to rho a v square. So that is going to be rho a v square is equal to this force is balanced by 310 Newton. Fantastic. Baba, use the Newton second law momentum equation for those of you who are not able to understand from where rho a v square is. I don't want to waste time in such simple things because अब machinery से लेके सारी जगह यार पढ़ते हो ये सब, so I don't want to waste time. So rho into a actual into v actual, okay, into v actual is equal to 310. मैंने थोड़ा सा separate किया. और second thing is someone will say, sir, why are you writing actual? Baba, 310 is a real life situation. So you have to balance with the real life things, that is the actual things, because this is coming from experimental studies. So it's not theoretical, it is actual. And v actual into a actual will be written as what? Actual discharge. Clear guys? So actual discharge is known to you. Rho, it is water, known to you, 310. Can you find the actual velocity from here? Yes. So when you are going to calculate actual velocity from here, this will come out to be 6.889 meter per second is the actual velocity. Now actual velocity is known, theoretical velocity is known, actual velocity is known, theoretical velocity is known. Can you find the value of CV? Yes. Will be V actual by V theoretical, which is under root of 2GH, and this will come out to be 0.9379. And you know how to find the value of CC, that is coefficient of contraction for an orifice. Come on guys, come on. Batao. CD will be equal to CC into CV. Beautiful relation. CD you know, CV you know. Can you calculate CC? Yes. CC will come out to be 0.83, and that's your answer. What a question, yaar. It's a mind-blowing question. It's a mind-blowing question. It's a mind-blowing question. My sessions, you see the quality of the numericals. You just see the quality of the numericals. But for understanding, you know, you should be well aware of your subject. You should be well aware of your subject, otherwise, again, wonderful question. Come on guys, read the problem. Come on guys, read the problem. Read the problem. एक बारी comment box में बताओ मजा आ रहा है कि नहीं आ रहा? Are you guys enjoying? I am enjoying. I am thoroughly enjoying. I'm thoroughly enjoying. You guys tell me in the comment box whether you are enjoying the subject questions or not. Very good. आ जाओ. A circular tank 2 meter in diameter has its axis vertical and contains 10 centimeter diameter orifice at its bottom. If the coefficient of discharge is given, remember this, estimate the time required. Unsteady state problem. Yes. Unsteady state problem. Unsteady state problem. Because you know nothing is coming into the container, the liquid is moving out of the container. So m dot in is not equal to m dot out, unsteady state problem. So the head he is asking you how much is the time required for the height to reduce from 3 to 2 meter. Come on guys, see. So initially original height is, let us say, 3 meter, and you want this 3 meter to reduce down to 2 meter, and that fellow is asking you that how much is the time required for the liquid to get reduced, because you know through this orifice the water is going to come out. Through this orifice the water is going to come out. Unsteady state problem. Now how to solve these kind of problems? Very simple here. Take a control volume. Take a control volume. Now for this control volume, Arey Baba, simple continuity equation, Baba, continuity. Take a control volume. take a control volume, take this fluid as your control volume. You know, with the height, the velocity of the liquid coming out from here is going to change. So directly you can't just find the time. Getting my point, bachcho? So here integration will be required. So for this control volume, nothing is coming in. M dot in is 0, but M dot out is there. M dot out is there. M dot out will be equal to discharge through the orifice, है ना? And that will be equal to rate of change of mass in your control volume. So therefore it is going to be M dot in minus M dot out. Beta, let us do some quality problems. Quality is going to survive at the end of the day. Is equal to d by dt, rate of change of mass in the control volume. So M dot in is 0. What is M dot out? M dot out is going to be discharge. Discharge will be area through which it is getting out. So area through which liquid is getting out is the orifice. So orifice area I am taking as A naught into velocity with which it is coming out. So velocity with which it is coming out, M dot is rho AV, okay, but area into velocity, again velocity will be under root of 2g h, under root of 2g h, and dear, under root of 2g h or whatever is the height, multiplied by density, rho AV, clear guys, is equal to, one more thing, see, look here. So therefore M dot is going to be rho into q. So my dear students, here you see this A naught into under root of 2gh is actually the discharge coming out. But you know there is a CD value given in the problem, and already the diameter of the container is given, so I have already found it out. Area of the container is A, area of the orifice is there, and the ratio of A by A naught, because we are going to utilize it for saving time, already I have given it in the given data, I have written here, okay, is equal rate of change d by dt of mass. Mass is what? Density into volume. Density into volume. Volume is going to be what? Area into h. And this height is of course going to change. So therefore this is going to be minus of A naught under root of 2gh into rho. Acha, one more thing I was telling you guys. This term is actually actual discharge. This term should be actual discharge. Area into under root of 2gh, but CD is given in the problem, na? So multiply this discharge with CD to convert into actual conditions so that we get the real thing. So this term should be multiplied with CD. Okay dear, so this term should be multiplied with CD. Beautiful. Is equal to, you know, rho and A has nothing to do with time. So rho is a constant with time, A is a constant with time, and you know, yes, so this is going to be dh. Height will change with time, na re baba, A dt. So what you need to find out? The time. So therefore from here you can find out the time. Time can be written as, see, rho and rho will get cancelled out. So time can be written as minus of A by A naught into CD into under root of 2gh, which is the initial height, into dh, very good. And you know there is this root h, because you need to integrate, na re baba. So h you should take in outside. Yes, so therefore h is going to come down. Just wait a minute. Look here, let me write this equation again, don't worry about anything. So therefore you need to find the value of dt. Let me write by another pen. So this is going to be A by A naught, A by A naught with a minus sign into under root of 2g, because h you need to integrate, and this will come into denominator, because to under root dt will come here and under root of 2gh will go there. So 1 divided by under root of 2g into cd, okay, and this will be dh by root h, okay, and integration of this will happen from initial height is 3, final height is 2. Come on guys, A by A naught ratio you guys know. I hope this integration will be 2 root h. Come on guys, are so many questions, so many students have given the correct answer here. I am very happy. Manish, Souvik, सचिन, अक्षत, संजय, दिल जीत लिया बच्चों. वेंकटेश, प्रतीक, दिल जीत लिया बच्चों. So this is integration of this is going to come out to be 2 root h. Now calculation is your responsibility. This integration will come out to be 2 root h and minus sign is there. So when you go for minus sign here, the limits will get reversed. It will become 2 to 3. Clear guys? And simply everything is given to you. Initial height, everything is CD value is also given to you. So when you are going to calculate the time from here, this will come out to be 91.1 second. This will come out to be 91.1 second. Wonderful. Very good यार. जरी वाला, सुफियान, सूर्या, प्रतीक, मजा आ गया यार, मजा आ गया. आप लोगों ने ये सॉल्व कर लिया. बहुत उम्दा, बहुत उम्दा. फैंटास्टिक क्वेश्चन. चलो अगले पे बढ़ते हैं, अगले पे बढ़ते हैं. यस, चलो क्या लिख रखा है? यस, these varieties are also important. A constant head water tank has on one of its vertical sides. So there is a tank on the vertical side of the tank. You have two identical orifices. Very important. Identical orifices. जहां से jet निकल रहा है, the distance between the center of the orifice is this, and jet trajectories intersect at a point 0.5 meter below the lower orifice. So that fellow is asking you that what is the approximate height, very good, of water level in the tank above the point of intersection of trajectories. This is your diagram. If you are not able to read the question, kindly concentrate on the diagram. Kindly concentrate on the diagram. See, so there are two orifices are there. There are two orifices are there, my dear students. Okay, two orifices are there. Let this be orifice 1. Let this be orifice 2. So orifice 1 and 2, the distance between their centers is given as 1.5 meter. So the jet which is coming out from 1 and jet which is coming out of from 2 is actually intersecting at this point at a distance of 0.5 meter below the lower orifice. At a distance of 0.5 meter below the lower orifice. Okay, so somewhere here both of them are intersecting. Then that fellow is asking you, find the total from this. Listen, important thing, he is not asking you h. A lot of students are going to give the answer as h. He is not asking you h. Let us read the numerical. What is the approximate height of the water level in the tank above the point of intersection of trajectory? So this is the point of intersection of the trajectory and this is the water level in the tank. So actually he is asking us to find out the total height. And you know this total height is going to be not h, this is going to be h plus 1.5 plus 0.5. So actually you need to find out the value of h for your final answer. How to solve, bacha? If you remember in classroom you would have been taught the experimental calculation of CV, coefficient of velocity. What is the formula for experimental calculation? Under root of x square divided by 4 by h, where x is the horizontal distance and y is the vertical distance from the center of the orifice till the reference point. Okay, but the important thing is both these orifices are identical. So CV for the first orifice and CV for the second orifice is going to be the same. So therefore x square for the first divided by 4y1 h1 is equal to x2 square divided by 4y2 h2. Someone will say, sir, where is under root? Someone will say, where is under root? Baba, both are equation, na? So you are squaring both sides. And you know x1 and x2 are the same. Why? Because they are intersecting, so the x value for both the jets is the same. Clear, guys? Now just concentrate here. What is the value of y1? This is important. Y1 is the distance of reference point from the center of the orifice. Reference point is this, center of the orifice is this. So the distance is 1.5 plus 0.5, so y1 is 2. Calculation is your responsibility. Calculation is your responsibility. And what is h1? h1 is the distance of center of the orifice from the top of the reservoir. Center of the orifice from the top of the reservoir, so this value is h. What is the value of y2, bacha? What is the value of y2? What is the value of y2? y2 is 0.5. And what is the value of h2, bacho? Bolo re baba. h2 is going to be 1.5. h2 is going to be 1.5 plus h. 1.5 plus h. Put all the values, find the value of h from here. So the value of h will come out to be 0.5. But h is not your answer, this is your answer. So answer is basically 2.5. How many of you got the answer? अरे वाह यार, मजा आ गया, मजा आ गया. मेहरा, अनुपम, दिलीप, स्निग्ध, विवेक, सौविक, युवी, रुपेंद्र, प्रियांश, क्या बात है यार, क्या बात है बच्चों. आ जाओ, चलो करो 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 करो. अगला क्वेश्चन, अगला क्वेश्चन. फोर्सेस ऑन पाइप बेंड का मैंने कोई क्वेश्चन नहीं चुना है, लेकिन इंपॉर्टेंट है, कर लेना, सारी चीजें इंपॉर्टेंट है. सो देयर इज दिस, लेट मी शो यू विद द डायग्राम. अ पाइप कैरिंग वाटर हैज इतना 30 centimeter cross 15 centimeter in a Venturi meter. So this is basically pipe diameter, okay, and this is basically throat diameter of the Venturi, which is positioned at an inclined angle of 30 degree to the horizontal. The flow is upwards, converging cone yes, is the converging length is 45 centimeter. CD value is given to be 0.98. A differential manometer is indicated having a column height of 30 centimeter. Calculate the discharge. This is your diagram. Come on, come on, come on guys. Come on, come on, come on guys. Calculate the discharge. आज हम रुकेंगे नहीं, आज हम रुकेंगे नहीं. बट सारी चीजें मेरी पेस मैच करने के लिए आप वेल वर्स्ड विद द क्लास नोट्स होने चाहिए, वेल वर्ड्स विद द टेक्निकलिटीज होने चाहिए, तभी आप एंजॉय कर पाएंगे. आ जाओ, देखो मेरी बात सुनो. Water is flowing through this. This Venturi meter is inclined at an angle of 30 degree, okay, and it is connected to this manometer. Manometer is of course, this is 1, this is 2. P1 will be greater than P2 because converging section, na, everybody knows. So therefore there is a deflection of 0.3 meter in this manometer, and this is mercury. He is and CD value is also given for this. D1 is given, D2 is given. He is asking you to find out the discharge in this. You know, the discharge for any Venturi meter, no matter whether it is horizontal, vertical, inclined, the discharge is given as CD A1 A2, that is the throat diameter, under root of 2GH divided by under root of A1 ka square minus A2 ka square. But wait my dear students, there is a trick everybody knows from classroom. This value of H, this value of H for an inclined Venturi meter is not the pressure head difference between pipe and throat. अरे जाग जाओ भाई, जाग जाओ, जाग जाओ, याद आ जाएगा. This is not the pressure head difference between pipe and throat. This is basically piezometric, for an inclined one, it is piezometric head difference between pipe and throat. So piezometric head difference between pipe and throat is P1 by W plus Z1, बच्चा P2 by W plus Z2. So actually, you know, in this formula, CD is known, A1 is known, A2 is known, A1 is known, A2 is known, 2 is known, G is known. If you want to find out the discharge, my dear student, this will be actual discharge, of course. If you want to find out the discharge, my dear students, you actually need to find out the piezometric head difference between the pipe and throat. And for calculating the piezometric head difference between the pipe and the throat, here is this manometer has been attached. Let us apply the jumping jack method on the manometer. Come on guys. If you're comfortable with the datum technique, you can use the datum technique. I don't have any problem with that. I don't have any problem with that. But I'm going to use the jumping jack method. And you know, already if you remember the classroom, always I have told that you should find this H in terms of flowing fluid. This head should be in terms of flowing fluid. So what is the fluid which is flowing through this Venturi meter? Water. So you should do all your calculation in terms of flowing fluid. So chalo, let us start our pressure calculations from here. What is the pressure at this point? Is going to be P1 by W. Is going to be P1 by W. Now from here you have to move vertically down up to this point. So vertically down is plus. Vertically down is plus. Flowing fluid only. Remember, we are doing this pressure calculation not in Pascal. We are doing this pressure calculation in terms of head. So this is P1 by W plus vertically down is X in terms of water only. Again from here to here this is 0.3 in terms of water only plus 0.3. Excellent students. Excellent students. Very good, my dear students. What is the next thing? So now you can jump from here to here. Now when you jump from here to here, you should move vertically up. So vertically up will be minus. But wait, this 0.3 meter is actually the head of Mercury. You should convert this head in terms of water head. How to convert this head in terms of water head? S1 H1 is equal to S2, come on guys, S1 Mercury head, so 13.6 is the into H1 is 0.3. You should convert this in terms of water head. This is 1 into H2. So therefore in terms of water head, this 0.3 meter height is going to be 13.6 into 0.3. Wonderful bachcho, wonderful. So therefore minus 13.6 into 0.3. You're doing all the pressure calculations in terms of head of water. Now from here to here vertically up, again minus X, and again from here to here vertically up. What will be this delta Z? Delta dash Z will be Z2 minus Z1, है ना? So minus vertically up to 2 point is Z2 minus, so minus Z2 plus Z1 is equal to P2 by W. Now comes the beauty. यार देखो x तो कैंसिल हो गया सारा, अपने को निकालना क्या है? पीजोमेट्रिक हेड डिफरेंस. अगर वो मिल गया तो मजा आ जाएगा. सो P1 by W प्लस Z1, ये देखो P1 by W प्लस Z1 माइनस P2 by W plus Z2 is equal to, can you calculate? Take it to this side, do the calculation. You will get this answer as 3.78. if my calculation is correct. You can cross check, cross examination after. See, calculation is not the problem is the concepts. Calculations can be cross checked, nothing serious about that. Now it's very simple. Once you get this, put it in this, you get all the values, find the value of discharge is your responsibility. Discharge will approximately come out to be 154 liter per second, and that's your answer. I hope some of you would have done. Arey wah, wonderful yaar. Wonderful. Yes, Abhi Sharma, correct answer hai beta. Sachin Sharma, very close. Sachin Sharma, very close. मजा आ गया. Fabulous problem. चलो आगे बढ़ते हैं. Yes, चलो पढ़ो. What is the problem? The outlet at the bottom of a tank is formed such that the velocity of water at A is 2 times the mean velocity means average velocity. Which is V. Within the outlet pipe, what is the greatest length which may be used without producing cavitation? Now how many of you know when the cavitation is going to take place? Cavitation is going to take place whenever the pressure of the fluid falls below the saturated pressure. Whenever the pressure of the fluid falls below the saturated pressure, then the cavitation is going to take place. Atmospheric pressure is also given, vapor pressure is also given, and yes, this is the diagram. So there is this tank is there in which some liquid is there and the water is flowing through this. There is some converging section is created here. Due to some deposition or something like that, some converging section is created here. So due to this converging section, everybody knows the velocity of the fluid flow will increase and the pressure will decrease. So here the pressure is going to be lesser. So if this pressure falls below the vapor pressure, then the cavitation will take place. Then that fellow is asking you to, and you know this velocity and things is going to depend on this length. You need to find out the value of this length such that no cavitation should take place. So what will be the critical condition, my dear students? What a fantastic question again here. What will be the critical condition? Yes, Anupam. Anupam you can use. Yes, बिल्कुल आप Anupam use कर सकते हो. X into S. x इंटू एस एम बाई एस माइनस वन, बिल्कुल आप यूज कर सकते हो अनुपम, वेरी गुड वेरी गुड, आपको क्लास की सारी चीजें याद है, जियो अनुपम। चलो इधर देखो, सो देयरफॉर हाँ, सो अगर मुझे कैविटेशन नहीं होने देना है, नहीं होने देना है, तो यहां का जो प्रेशर है वो वेपर प्रेशर से नीचे नहीं आना चाहिए। सो अगर मुझे क्रिटिकल लेंथ निकालनी है तो मुझे अपने कैलकुलेशंस में यहां के प्रेशर को वेपर प्रेशर से इक्वेट करके लेंथ निकालनी चाहिए, वो क्रिटिकल लेंथ होगी। आई बात समझ? यस, सो ही इज आस्किंग द क्रिटिकल लेंथ। आओ लेट अस अप्लाई द बर्नौली इक्वेशन बिटवीन 1 and 2. Let us apply the 1 and A first of all, because converging section na 1 and A. Let us find out the Bernoulli's equation between 1 and A. So that is going to be P1 by W plus V1 ka square by 2G plus Z1 is equal to PA by W plus VA ka square by 2G plus ZA. Wonderful. So losses are not given, so therefore this is going to be your equation. You know P1 by W is 0. One more beautiful thing. Yes. Look here. This is the Guru Mantra for today. Take this. This is the Guru Mantra for today. The Guru Mantra is, whenever generally what we do is, we in our calculation we solve with by taking gauge pressure. In our Bernoulli's equation, if you remember our classroom, maximum questions, almost 99% question, we take gauge pressure, we solve. We take gauge pressure, we solve. Final answer also comes in terms of gauge. But remember this Guru Mantra, whenever in any question cavitation is involved, you kindly consider the atmospheric pressure and find. So always whenever cavitation is involved, go for absolute. So P1 I am not taking 0. P1 is given in the problem. P1 will be equal to atmospheric pressure, which is how much? 95.480 into 10 to the power 3 divided by W. It is water, so 9810. Okay dear, plus, yes, now this can be taken, V1 can be taken as 0 because it's a large tank, so velocity can be taken to be negligible, plus Z1. So when you are applying between 1 and A will be taken as the reference, and Z1 will be 1.50 meter. So this is 1.50 is equal to pressure at A. And I told you guys, to find out the critical condition, this PA should be taken equal to PVS. And how much is PVS given? 4 kilopascal. That is 4 into 10 to the power 3 divided by W, which is specific weight of water, which is 9810, plus VA you need to find out, VA ka square by 2G, and ZA is 0. You have taken this as reference. So from here, can you calculate the value of VA? Yes, you can. So this is going to be 14.57 meter per second is the value of VA. 14.57 is the value of VA. Wonderful. Priyansh, beta, we are trying to find out the critical condition. So this is going to be the value of VA. It is given in the question that VA is actually 2 times the velocity at exit of the pipe. So let the velocity at the exit of the pipe is V2. So it is given to be here. So VA is known. Can you find the value of V2 from here? Yes. V2 will be half of VA, which will be 7.286 meter per second. Now the question is over. What will be next step? Apply Bernoulli between 1 and 2. You will get the value of L. Okay, apply Bernoulli between 1 and 2. Now it is your responsibility here. Apply Bernoulli between 1 and 2. P1 by W plus V1 ka square by 2G plus Z1 is equal to P2, which is the exit, plus V2 ka square by 2G plus Z2. Z2 is the lower thing, so you will take as reference. This is gone. P1, don't take it to be 0, take it to be atmospheric. 95.480 kilopascal. 95.480 into 10 to the power 3 divided by W. W specific weight of water 9810. Okay dear, plus V1, just now we have found it out the value of V1, where V1 is a large tank here. This is also gone, plus Z1. Z1 will be 1.50 plus L. Z1 will be 1.50 plus L. Very good. Is equal to P2. P2, what is the pressure at 2? Atmospheric. Arey wah. So both the sides the pressure is atmospheric. So this and this can be cancelled. Because P2 will also be this na. 95.480 into 10 to the power 3 divided by 9810. So you know this and this can be cancelled out easily. Plus V2 you have found it out 7.286. 7.286. Okay. Square divided by 2 into 9.81. Wonderful. So from here you can calculate the value of L. This will come out to be 1.21 meter and that's your answer. Fantastic question yaar. अव्वल दर्जे का क्वेश्चन था. अरे वाह. नेहा, सौविक, इंद्रेश, प्रियांश, अभदेश, हर्ष. क्या बात है बच्चों. A lot of students are again and again asking. देखो रीड करो क्वेश्चन को जब तक मैं थोड़ा ब्रीफ कर दूं. A lot of students are again and again asking that sir, will this lecture be available afterwards also? Let me say it again. Yes, this lecture will be available afterwards. It will be public in the YouTube. Okay, so you can note down all the questions afterwards. At the moment, practice with me. At the moment, practice with me. Second thing is, last year I took GTQ 1 and hydrostatic force class and curved surface class. The links of those videos I will put in the comment box so that you are able to get a holistic approach. और numericals मिल जाएंगे क्योंकि last year का GTQ बिल्कुल अलग था. इस year का GTQ एकदम नए questions, brand new. तो आप देख रहे हो कितने सारे एक्स्ट्रा क्वेश्चंस मिल रहे हैं आपको. आ जाओ, करो बेटा, करो. डायनेमिक विस्कोसिटी इतना इतना, पॉइज फ्लोज बिटवीन टू फिक्स पैरेलल प्लेट्स. पैरेलल प्लेट्स का क्वेश्चन है यार. फिक्स पैरेलल प्लेट्स. मीन वेलोसिटी बोले तो एवरेज वेलोसिटी. कैलकुलेट मैक्सिमम वेलोसिटी, बाउंड्री शियर स्ट्रेस, वेलोसिटी एंड शियर स्ट्रेस, हेड लॉस. सारी चीजें आपको निकालनी है. टू पैरेलल प्लेट्स आर फिक्स्ड. डेंसिटी ऑफ द फ्लूइड इज गिवन. Basically laminar flow between two fixed parallel plates is, assume the flow is laminar. Let me write here एक assumption है यहाँ पर. Assume flow is laminar. Assume the flow is laminar. Assume the flow is laminar. आ जाओ बच्चों, करते हैं शुरू. देखो एवरेज वेलोसिटी हम लोगों को दे रखा है, वो हमसे मैक्सिमम वेलोसिटी पूछ रहा है. फॉर्मूले याद होने चाहिए. इफ यू रियली वांट टू सॉल्व दिस क्वेश्चन यू नीड टू रिमेंबर द फॉर्मूला. इफ यू रिमेंबर फॉर पैरेलल प्लेट्स, लेमिनार फ्लो बिटवीन पैरेलल प्लेट्स, द वैल्यू ऑफ u max by v is actually 3/2 which is 1.5. The value of v is given to you in the problem. Average velocity 1.40. So can you find the value of u max directly? Yes. So when you are going to calculate this, this is going to come out to be 2.10 meter per second. So the first part is solved. Next, what he is asking you? He is asking you shear stress at the boundary. Shear stress at the boundary is asking you. In the beta, for solving this problem, you need to remember all the formulas of parallel plate that have been derived beautifully in the classroom यार. क्लासरूम में ब्यूटिफुली आपको डिराइव करवाए हैं, वो सारे फॉर्मूले याद होने चाहिए आपको. व्हाट इज द वॉल शियर स्ट्रेस? Wall shear stress or the maximum shear stress, the formula is minus of del P by del X into T by 2. This is your formula. So T is the distance. T is this distance between the plates. Okay dear. But for finding this you need to find out the value of del P by del X. First of all, you need to find out the value of del P by del X. Now, how to find out? See, you already have the average velocity. So, I hope you guys remember the formula for average velocity. What is the formula for average velocity, beta? From your derivation, minus 1 by 12 mu into del P by del X into T square. I hope you guys remember. Now, you see, average velocity is given to you, 1.40. 1.40 is equal to 1 by 12 mu is given to be as 0.105. okay dear, minus of del P by del X del P by del X into T square. This is 1.2 centimeter. So T square 0.012 ka square. So from here, can you find out the value of del P minus of del P by del X? Yes. So when you are going to calculate this, my dear students, you are going to get the value as 12250 Pascal per meter. Look at the effectiveness here. एक सेकंड भी हम वेस्ट नहीं कर रहे हैं, नॉट इवन अ सिंगल सेकंड. ये डेल पी अब आपका रिस्पॉन्सिबिलिटी है. अब मैंने बता दिया, आपको हिंट दे दिया है क्या करना है इसमें. अब आप ही लोग सॉल्व करो इसको. टी का वैल्यू आपको पता है, ये पता है आपको क्या वॉल शियर स्ट्रेस या मैक्सिमम शियर स्ट्रेस आपको मिल जाएगा. आंसर में लिख रहा हूं 73.5 पास्कल आएगा. 73.5 पास्कल आएगा. ठीक है. अगली बात क्या है, और क्या पूछ रहा है आपसे. He is asking you velocity and shear stress at a distance of 0.2 centimeter from the plate. Everybody knows from the plate, if you are asking any distance, that is shown by the symbol y. Y is the distance from the boundary, na? So he is actually asking you to find out the velocity and the shear stress at a distance of at y is equal to how much, bacha? How much it is given here? He is asking you at a distance of, yes, 0.002 meter. At a distance of 0.002 meter. Simple. You have to do your calculations. It is your responsibility. Everybody knows the velocity distribution for your laminar flow between two fixed parallel plates is basically given by 1 by 2 mu minus of del P by del X Ty minus y square. Everything is known to you. Just put the values, get the value of u at a y value you will put as this. Let me give you the answer. This will be 1.167 meter per second. Okay dear. And wall shear stress formula is, everybody knows here, minus of del P by del X T by 2 minus y. Arey baba. This is the formula for, I told you ना, आपको पूरा क्लास की चीजें याद होनी चाहिए. तभी आपको जब पता था कि सर सेशन लेने वाले हैं तो रिवाइज ही कर लेते एक रात पहले, मजा आ जाता. हाँ, क्या होता है T by 2 minus y. This is the formula for shear stress. सारी चीजें पुट करिए, क्या आंसर आएगा आपका. So tau value will come out to be 49 Pascal. Tau value will come out to be 49 Pascal. Head loss value everybody knows. Head loss value is going to be P1 minus P2 by W, and drop of pressure for your is 12 mu VL by T square, है ना, into W. अरे drop of pressure बाबा, P1 minus P2 formula is 12 mu VL for parallel plates. Put everything, the value of head loss will come out to be 33.93 meter, and that's your answer. Fantastic question. Let me check how many of you got the answer. Let me check that. Yes, 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 wonderful yaar. Subrata, Shaurya, Anupam, Abhi, Rakesh, Manish, अरे वाह, अरे वाह, जिंदा रहो बच्चों, जिंदा रहो, जिंदा रहो. अभी देखो और ब्यूटीफुल प्रॉब्लम्स आ रहे हैं बोर्ड पे. एन ऑयल ऑफ डेंसिटी इतना, ऑयल ऑफ डेंसिटी इतना, एंड काइनेमैटिक विस्कोसिटी इतना, flows upward through an inclined pipe as shown in the figure. P1 is given, P2 is given, everything is. You need to find out head loss, velocity, discharge and Reynolds number, assuming the flow to be laminar. Assuming the flow to be laminar. Fantastic set of questions. So this is your diagram. There is this pipe is there having a diameter of 6 centimeter, length is 10 meter, and this angle is 40 degree. Angle is 40 degree bacha. Okay, and P1 pressure at 1 point is given, 2 point is given, density is given, and kinematic viscosity is also given. See, you need to find a lot of things, but here in the question he has written verify that the flow is upwards. What do you mean? This kind of question has come in GATE paper. This, why I have taken this question is, this variety of question has come in GATE paper. Come on guys, first of all you need to verify that whether the flow is taking place from 1 to 2 or from 2 to 1. So he is asking you to verify the direction of the flow. Come on guys, how do you verify the direction of the flow? By the fluid always flows from higher total energy to lower total energy. Now in fluid mechanics, the total energy means sum of pressure plus kinetic plus potential, है ना? But you know at 1 and 2, as this is a constant cross section pipe, the kinetic energy will be same. So kinetic energy is not going to play any role in deciding the direction because its value is the same both. Okay. So who is going to decide then? Piezometric head actually. So let us find out first of, Arey Baba, see here the viscosity is given bacha. This means this is not an ideal situation, it's a real situation. So instead of applying the classical Bernoulli's equation, we will apply the modified Bernoulli's equation here, okay. So let us go for piezometric head at point 1. Let us go for piezometric head at point 1. So piezometric head at point 1 is going to be P1 by W plus velocity head you need not take because it will be same plus Z1 is equal to, okay, P1 is given, come on guys, do your calculations, 35 into 10 to the power 4 divided by W, some oil is flowing having a density 900, so 900 into 9.81 plus Z1. See, while calculating energy you need the vertical distance, so this distance is 10 meter, so this vertical distance will be 10 sine 40 degree. It's a mind boggling problem here, 10 sine 40 degree. So plus 10 sine 40 degree. So while calculating energy, 1 you will take, acha, 1 you are taking as reference here. No need to take this, 1 you are taking as reference. So Z1 will be 0. Arey Baba, during energy calculation for easiness, the lower point you are taking as reference in Bernoulli, na? So this is 0. So what is the value of this? So when you are going to calculate this, this will come out to be 39.64 meter. Similarly, let us find the piezometric head at point 2. Piezometric head at point 2 is going to be P2 by W plus Z2, and Z2 will be 10 sine 40 degree. So P2 is 25 into 10 to the power 4 divided by W, which is 900 into 9.81 plus 10 sine 40 degree. Come on guys, solve is equal to, क्या आ जाएगा बेटा ये? This will be 34.74 मीटर. इस तरीके का क्वेश्चन गेट के पेपर में लिंक्ड डेटा वाले क्वेश्चन में काफी पहले आ चुका है. So these, don't think that these are long problems here. In a single problem, if you are finding multiple things, automatically what the teacher is trying to do है कि हम एक बड़े problem के माध्यम से छोटे problems जो गेट के हैं उनको automatically attack कर रहे हैं यार. So here as piezometric head of 1 is greater than piezometric, therefore it is confirmed that the flow is from, once it is confirmed that the flow is from 1 to 2, let us apply the Bernoulli's equation between 1 and 2. So Bernoulli's equation between 1 and 2 is going to be total energy at 1. Total energy at 1 is going to be piezometric head at 1 plus the kinetic energy at 1 is equal to piezometric head at 2 plus the kinetic energy at 2. Arey Baba, what is total energy? Piezometric head plus the kinetic head plus head loss. Kinetic energy at 1 and 2 is going to be same. Piezo, already you have to find out, will you get the value of head loss? Yes. Head loss will come out to be 4.89 meter. 4.89 meter. Once you get the value of head loss, everybody knows head loss is FLV square by 2GD. FLV square by 2GD. Okay. Now calculations you have to do. I will give you hint. See, here everything is, you can find out the velocity from here, but you need to find out friction factor. It is given that it is a laminar flow. So friction factor will be 64 by Reynolds number. Reynolds number is rho VL by mu. Rho VD by mu. So what you do is, देखो बच्चों कैलकुलेशन आपका जिम्मेदारी है, मैं आंसर बता रहा हूं. इधर देखो, F का वैल्यू इसके अंदर पुट करिए, हेड लॉस निकालिए. F का वैल्यू इसके अंदर पुट करिए, हेड लॉस निकालिए. ओके, F का वैल्यू इसके अंदर पुट करेंगे. ओके, एंड हेड लॉस आपको पहले से पता है, यहां से क्या निकल आएगा? वेलोसिटी. सो वेलोसिटी विल कम आउट टू बी 2.69 मीटर पर सेकेंड. वंस द वेलोसिटी इज नोन, यू कैन फाइंड द डिस्चार्ज. डिस्चार्ज विल बी एरिया इनटू वेलोसिटी, एंड दैट विल कम आउट टू बी 7.63 into 10 to the power minus 3 meter cube per second, and Reynolds number will be 807. Reynolds number बच्चे रो वी डी बाय म्यू. Rho V d by mu will be 807. Wonderful, yaar. Yes, Pradeep, Ashirwad, all are correct. All are correct. Very good. चलिए let us move forward. Beautiful problem. Let us move forward. आज हम रुकेंगे नहीं, थकेंगे नहीं, लेकिन एफएम की पूरी तैयारी होनी चाहिए, तभी आपके क्वेश्चंस पल्ले पड़ेंगे, तभी आप एंजॉय कर पाओगे. ये देखो क्या बेहतरीन क्वेश्चन है बोर्ड पे, क्या बेहतरीन क्वेश्चन है बोर्ड पे. रीड करो जरा. A rectangular duct having a width इतना has a 2D irrotational flow. 2D irrotational flow has an elbow. Elbow means bend. Elbow means what? Bend. Made up of circular areas of radius 40 centimeter and from the inner to outer wall. Assuming the flow in the elbow to be an irrotational vortex, we are equal to constant. Arey baba, if in every batch of Made Easy I have taught this beautiful thing that the flow of fluid in a pipe bend, the flow of fluid in a pipe bend is a free vortex. Is a free vortex, and for free vortex what is the governing equation? V r equal to constant. And in case of free vortex, as the radius increases, the velocity decreases. From the inner side of the bend, remember our classroom discussion, from the inner side of the bend to the outer side of the bend, the velocity is going to vary. Velocity is going to vary, it is going to decrease, and there is a redistribution of velocity as well as pressure from the inner side of the bend to the outer side of the bend. And you know that pressure differential is given as 30 kilopascal, and that fellow is asking you, to find out the discharge through this. Now see, what is the problem? The depth of this is 1, this is 25 centimeter, this is a bend is there, R1 is given to be as 40 centimeter, R2 is outer side distance, radial distance is given as 65 centimeter. Now what is the problem? If you want to find out discharge is area into velocity, okay, but the problem is the velocity is not constant, the velocity is varying. Velocity is varying from inner side to the outer side, there will be redistribution of velocity. So directly you cannot solve, so you need to integrate, but so as it is a free vortex motion question, free vortex is V r equal to constant. Let us apply Bernoulli's equation between 1 and 2, that is inner side, because in case of free vortex you can apply the classical Bernoulli's equation. So this can be written as P1 by W plus V1 का square by 2G plus Z1 is equal to P2 by W plus V2 का square by 2G plus Z2. My dear students, it's in horizontal plane, so Z1 Z2 तो गए, P1 अच्छा P2 minus P1 करेंगे, so P2 minus P1 by W, P2 minus P1 by W, P2 minus P1 by W is going to be V1 का square minus V2 का square by 2G. V1 का square minus V2 का square by 2G. You know this pressure differential is already given in the question as 30 kilopascal, but the velocity is varying, so let us convert. Everybody knows Vr is a constant, let us convert in terms of radius. So therefore you can write the velocity as C by R. So this can be written as 30 into 10 to the power 3 divided by W, water is flowing, so 9810 is equal to 1 by 2G. V1 can be written as C square by R1 square minus C square by R2 square. Now look here, everything is known to you, R1 is known, R2 is known. Can you find out the value of constant? Yes, 3.93 is the value of constant. Now the question will be solved. How? See, let us integrate radially. So let us take a small section dr, and for this small section let us find the small discharge. So for this small section, the small discharge is going to be velocity multiplied by dr, will be velocity multiplied by dr, and integrating it from R1 to R2, integrating it from R1 to R2. integrating it from R1 to R2. Bacha, this dr cross 1 is the area, na? So velocity into, but velocity is varying. So we will replace this velocity R1 to R2 by C by R. Into dr. So dr by r, integration will be log r, and this is going to be there. So constant you can take outside, integration of this will be log r, and upper limit minus lower limit. So this is going to be log of r2 by r1. The question is solved. The question is solved. You know the value of C, you know the value of r2, you know the value of r1. The discharge, the total discharge will come out to be, okay, so you have integrated now. So this is total discharge. So total discharge, fabulous question yaar, fabulous question, wonderful, fabulous question, mind boggling problem. Come on, come on, come on guys. If you have the guts to match up with my speed, but you should, what a question. Just look at the beauty of the question. What a beautiful question yaar. Definitely, देखिए जो हम क्लासरूम में पढ़ते हैं वो तो सब है ही है, कुछ अलग भी तो होना चाहिए ना, क्योंकि हम अगर देखो क्लासरूम वाली चीज में तो हम कॉन्फिडेंट हैं ही, समझ रहे हो बात को, तो अगर कुछ चीजें अलग हैं उनको अगर हम सॉल्व करेंगे, उनमें मजा करेंगे, तो दैट इज द मोस्ट अल्टीमेट पार्ट, दैट इज द मोस्ट अल्टीमेट पार्ट. ओके, दैट इज माय कॉन्सेप्ट बिहाइंड दिस GTQ, दैट इज माय कॉन्सेप्ट बिहाइंड GTQ. आओ इधर देखो, इधर देखो, a two-dimensional conduct velocity distribution is shown here. So this is some conduct is there, rectangular conduct is there, and two-dimensional. Calculate the kinetic energy correction factor. Oh my God, kinetic energy correction factor, if you remember, integration 0 to r for a circular pipe is u cube dA divided by AV cube. कुछ याद आ रहा है भूली बिसरी यादों में, है कुछ याद आ रहा है भूली बिसरी यादों में? अल्फा का वैल्यू याद आ रहा है बच्चों? देखिए, ओनली सीरियस स्टूडेंट्स आर गोइंग टू सर्वाइव इन दिस GTQ. अल्फा कुछ याद आ रहा है, बट यहां पर 0 to b करेंगे क्योंकि ये कंडुइक्ट है. आओ देखो, ये कंडुइक्ट में पूरा फ्लो नहीं हो रहा है, केवल इस रीजन में फ्लो हो रहा है एट अ स्पीड ऑफ u. बाकी यहां पर कोई देखो, सिर्फ यहां पर वेलोसिटी डिस्ट्रीब्यूशन दिखा रखा है उसने डायग्राम में, कांस्टेंट है u फ्रॉम 0 to 2b by 3, and from 2b by 3 to b the velocity is 0, u is 0. Okay, see here, so u is constant from here to here, ठीक है, and u is 0 from here to here, and this is your kinetic energy correction factor, and this is a conduct, so we are going to do from. So for finding this, you know, first of all you need to find out this average velocity. So how to find out the average velocity? Average velocity will be discharge by area. What is the discharge of the fluid through this conduct? Very simple. Discharge is only taking place from here, in this particular area only. Otherwise here the discharge is 0. So the discharge flowing through this is going to be area. How much is the area? How much is the area through which the flow is taking place? Just look at the quality of the question here. Something different. Something different. देखो, नॉर्मल चीजें तो आप कर ही लोगे यार, बट गेट का पेपर देने जा रहे हैं, IQ की टेस्टिंग है, वहां पर चीजों की टेस्टिंग है. लेट अस बी प्रिपेयर्ड विद सम डिफरेंट थिंग्स. सो 2b by 3 into velocity. Velocity is how much? U. Velocity is u. That's it. Because other is 0 divided by area. Area of the conduct is b cross 1. So this is, so what is the average velocity? 2u by 3 is the average velocity. So average velocity you have got. Next you need to find out integration 0 to b u cube dA. Now just look here. Look here. Can this total integration from 0 to b can be divided into two parts? Yes. From 0 to 2b by 3 and from 2b by 3 to b. Okay. So therefore this can be divided 0 to 2b by 3. Here the velocity is u cube into dA. Into dA. Clear guys? Plus integration from 2b by 3 to b. Okay, but here the velocity is 0, so you know this term is going to be 0. Why? Because the velocity in this section is going to be 0. What a fantastic question here. What a fantastic question. Now it is very simple. Beta u is a constant. u is a constant, and area is your b cross 1, this 2b by 3 is the area. So you need to integrate करिए, आंसर निकालिए, क्या आंसर आएगा? अच्छा, you are integrating with respect to y ना, so area is y dy, this is dy cross 1, because yes, very good, come on guys. So therefore this is 0 only, so this is dy. So integration will be y, and when you put the limit, you can, u is a constant, can be taken outside, so integration will happen. So this value will come out to be, yes, this value will come out to be u cube y, and limits will be from 0 to 2b by 3. So this is the numerator, and denominator is area, which is b cross 1 into v cube, okay. So when you are going to solve, this is going to come out to be 9 by 4, and that is 2.25. so this is your value of alpha. Again a mind boggling question. क्या बात है, impulse solid works, बेटा तेरा नाम सही से नहीं लिखा हुआ है, नहीं तो मैं लेता impulse solid works. ब्यूटीफुल आंसर, ठीक है बेटा तुम्हारा. प्रदीप, प्रियांश, विक्रम, सचिन, सौविक, सुधांशु, हर्ष, सुब्रता, मजा आ रहा है कि नहीं बच्चों? बताओ कितनी डिफरेंट चीजें सीखने को मिल रही हैं, कितनी डिफरेंट चीजें सीखने को मिल रही है. चलो ये देखो ये क्वेश्चन, चलो ये देखो ये क्वेश्चन. कम ऑन गाइस, come on guys, look here. A horizontal pipe of diameter d1 has a sudden expansion of till diameter d2, okay. What is the ratio of sudden expansion? Do you guys remember sudden expansion? Do you guys remember what is the formula for head loss due to sudden expansion? Is basically v1 minus v2 ka whole square by 2g. If you remember, smaller pipe velocity minus larger pipe velocity whole square by 2g, okay. Differential pressure on either side of the expansion will be maximum. Yes, there will be a pressure difference created now. See, this is sudden expansion case. This is sudden expansion case. So here the things are getting suddenly expand. So this is sudden expansion basically, and here the loss is taking place, okay dear. Now you see, this is a smaller diameter pipe, so the velocity will be high, so pressure will be less, and here the velocity will be lesser, suddenly the velocity will become lesser, so the pressure will be very high. What a question here, what a question. So therefore P2 will be more than P1. So what is P2? Pressure just downstream of the, see this region is sudden expansion, so P2 is the pressure downstream of this. See the variety, see the quality exists. दिमाग के घोड़े दौड़ने चाहिए भाई, तभी मजा आएगा. और नॉर्मल चीजें तो सभी हो गया, लेकिन कुछ एक्स्ट्राऑर्डिनरी बढ़िया चीजें होनी चाहिए. आओ इधर देखो. So just downstream of sudden expansion, and P1 is the pressure which is upstream. Which pressure will be more? Of course P2 will be more than P1. So that fellow is asking you, what is the diameter ratio? This smaller pipe diameter is D1, larger pipe diameter is D. So he is asking you the ratio of D1 by D2. At what ratio of D1 by D2 this pressure differential is maximum? This pressure differential is maximum. Now only those students can solve this problem who are well versed with the derivation of sudden expansion loss. And you know, in all my classes I have done the derivation in the classroom. आपको अगर derivation आता है तभी आप ये question कर पाओगे, नहीं तो फिर बड़ा problem है. So we are talking about just upstream and downstream pressure of the sudden expansion. So let us take two sections in the sudden expansion, upstream and downstream 1 and 2. Let us apply Bernoulli's equation between 1 and 2. Come on guys. So this is going to be P1 by W plus V1 ka square by 2G plus Z1 is equal to P2 by W plus V2 ka square by 2G plus Z2 plus head loss. Look, when you are applying Bernoulli's between 1 and 2, there is going to be this loss. What is this loss? Sudden expansion loss. sudden expansion loss, whose value you guys already know is V1 minus V2 का whole square by 2g. Is V1 minus V2 का whole square by 2g. Horizontal thing only, and we want P2 minus P1. We want P1 minus P2. We want P1 minus P2. Okay. We want P1 minus P2. We want the drop of pressure. So therefore, acha, wait. What is the differential pressure on the either side of the expansion is maximum. So therefore, from here, can you find the drop of pressure? See, V1 and V2, you take it to that side. So P1 minus P2 by W is the drop of pressure, is equal to V2 का square minus V1 का square, V2 का square minus V1 का square by 2g plus head loss, which is V1 minus V2 का whole square by 2g. Clear guys? So from here you just take 2g as common. Beta ये आप ही को करना है. You have to do this. I am telling you how to solve. I am telling you how to solve. Come on guys. Yes, yes, yes. So therefore 2g you can take as common here, and V2 का expand this, V1 का square plus V2 का square minus 2V1 V2. So from here you will get the drop of pressure value. This can be written as rho g. Okay, so that can be written as rho into, this will come out to be V2 का square minus V1 V2. Clear? I'm saving time because I have to solve a lot of questions. That's why. Come on guys. So this is the change in pressure. You need to maximize this change in pressure, but with respect to diameter. So how to convert these velocities in terms of diameter? Go for continuity equation. A1 V1 is equal to A2 V2. So therefore pi by 4 into D1 का square into V1 is equal to pi by 4 into D2 का square into V2. So pi by 4 is gone. Can you find the value of, from here, can you find the value of D1 by D2? Yes, you can find out. Or simply you need to replace V2. Let us replace V2. So therefore find the value of V2. So V2 will be D1 by D2 का square into V1. Clear guys? Yes. Now for simplification of our calculations, let us take D1 by D2 as X. Let us take D1 by D2 as X and put the value of V2 in this. Put the value of V2 in this. Come on guys, this is an important one. So therefore let me help you out. So finally I am writing, when you are going to put the value of V2 in this, calculation is your responsibility. So delta P will come out to be rho V1 square x to the power 4 minus x square. This is going to be there. So this pressure drop you need to maximize with respect to diameter and diameter ratio. So diameter ratio is taken to be as x. So how to maximize the thing? Differentiated with respect to variable and put it equal to 0. So this, from here when you put it equal to 0, this will come out to be 1 by root 2. Clear guys? This is P1 minus P2, upstream to downstream pressure ratio. Beautiful problem yaar. But only those students will be able to solve. Beautiful yaar. ये तो देखो, ये तो चाहे गेट हो चाहे इंजीनियरिंग सर्विसेज हो, ये क्वेश्चन तो इतना फेवरेट है उन लोगों का कि हर जगह पूछा हुआ है. आओ बच्चों सॉल्व करते हैं. A compound piping system consists of 3 pipes. The length of first pipe, diameter is given. Length of second pipe, diameter of second pipe. Length of third pipe, diameter of third pipe is given. And pipes of the same material, just to signify that friction factor for all the pipes is the same. Friction factor, this is important one, because a lot of times in GATE paper and engineering services these kind of questions are asked. Okay, beautiful problem. चलो करो, देखो सबसे पहला तो क्या है, what is the equivalent length? Do you know the concept of equivalent pipe? Come on guys, revise with me. What is an equivalent pipe? An equivalent pipe is such a pipe to the compound pipe for the connection in series or for the connection in parallel, a equivalent pipe is going to be such a pipe such that the head loss is same as that the your system of connections, and the discharge should also be the same. Such a pipe is known as equivalent pipe. But here what will be the, see, first of all it is connected in series. So if the three pipes are connected in series, equivalent length is given to you, LE is given to be 40 centimeter. He is asking you, okay, so this is the diameter, D is given to you. D is given to you. He is asking you to find out the value of LE. How to do it? Everybody knows for series connection, Dupuyt's formula from the classroom, beautifully derived in the classroom. What is Dupuyt's formula? LE, see, for GATE examination, directly you have to remember, bhai, LE by DE to the power 5 is equal to L1 by D1 to the power 5 plus L2 by D2 to the power 5 plus L3 by D3 to the power 5. My dear students, DE is given to you, L1 D1, L2 D2, L3 D3, everything is given to you. Can you find out the value of LE? Yes, 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 you can find out. LE will come out to be 4318.2 meter. 43. थक तो नहीं गए बच्चों? अरे वाह, बहुत लोगों ने सही आंसर दिए. अनिकेत, अभी, सचिन, बेटा थक तो नहीं गए तुम लोग? अरे यही तो मेहनत का टाइम है यार. थकते ही रहोगे क्या? जिंदगी भर थकते ही रहोगे क्या? यही तो मेहनत का टाइम है. जितना मैक्सिमम हो सकता है ग्रास्प करके लेकर जाओ यार. यूट्यूब सेशन पे मेड इजी के टीचर्स आ रहे हैं, जितना मैक्सिमम हो सके ग्रास्प कर ले जाओ. मैं तो कह रहा हूं लूट लो यार. Are you just look at the quality of the questions here? These are not normal stuff questions. What is the equivalent size of the pipe? Okay, and now he is asking for equivalent diameter. When the equivalent length is given, so LE is given. LE is given in the second part. LE is given. He is asking for DE. So you need to solve by Dupuyt's formula again. That is going to be 38.57 centimeter. Now, the third part of this problem is the one which I mainly care for. What is given in the third part? Look here. If the three pipes are now connected in parallel, generally in the classroom, what we do is we take similar pipes in parallel. Similar pipes. What do you mean by similar pipes in parallel? Similar pipes in parallel are the one whose length and diameter are the same. But here he is saying the pipes are connected in parallel, but these pipes are not similar pipe because the length and diameter of all the three pipes are different. What a mind-boggling problem here. Then he is asking, remember, generally we go for similar pipes, but here this is not similar pipe. This is our dissimilar pipes are there. He is giving you equivalent length. Okay, you need to find out equivalent diameter. Now here to save time and give you the purest knowledge, what I have done is I have already written something on board. I will explain what I have written on board just to save time so that we are able to solve more number of numericals. For dissimilar pipe, how to find out a relation between LE, DE and the length and diameter of the various pipes. See, for parallel pipe connections, everybody knows what is the condition for parallel pipes. For parallel pipe connection, the head loss in all the pipes which are connected in parallel is the same. So head loss is 1 is equal to head loss in 2 is equal to head loss in third pipe. And what is the condition of equivalent pipe? Come on guys, दिमाग का चक्का चलना चाहिए. बताओ आप लोग, इक्विवेलेंसी की क्या कंडीशन होती है? जो भी आपके पैरेलल कनेक्शन के पाइप्स हैं उनमें जो लॉस हो रहा है और जो इक्विवेलेंट पाइप में लॉस हो रहा है वो सेम होना चाहिए, है ना? सो लॉस इन 1 इज इक्वल टू लॉस इन 2 इज इक्वल टू लॉस इन 3 सम head loss in equivalent pipe is equal to some loss HL. Okay, so therefore what is loss? FLV square by 2GD, FLV square by, and for equivalent pipe, let for equivalent pipe the length of equivalent pipe is LE, let the diameter of the equivalent pipe is D. Clear guys? So therefore this is the thing is equal to HL. So let us equate Okay, so let us equate this and this. So when you equate this with this, from here, can you calculate the value of V1? Yes, you can calculate. On the next slide, I have calculated. See, please, after this lecture, you can note this down in your register, whatever I am doing on board. So this is going to be the value of V1. So discharge for the first pipe is going to be A1 V1 multiplied with A1, which is pi by 4 D1 square. When you multiply this with this, you will get Q1 as this. Similarly, can you find Q2 and Q3 and QE? Similarly, find V2 by equating the loss with HL. Find V3 by equating the loss with HL. Find VE, equivalent velocity. Okay, so in the same manner you can find Q2, Q3 and QE. Now what is the final thing? Everybody knows that for parallel connection, the total discharge is the summation of individual discharges. So how much is the discharge taken by these dissimilar pipes in parallel? This is the discharge taken by dissimilar. And what is the condition of equivalency? That whatever जो पैरेलल कनेक्शन के पाइप हैं वो जितना डिस्चार्ज ले जा रहे हैं, इक्विवेलेंट पाइप, एक ही पाइप उतना डिस्चार्ज ले जाना चाहिए. ठीक है. सो द समेशन ऑफ दिस डिस्चार्जेस थ्रू दिस थ्री डिसिमिलर पाइप शुड बी इक्वल टू द डिस्चार्ज ऑफ द इक्विवेलेंट पाइप. देन ओनली इट विल बी कॉल्ड एज इक्विवेलेंट ना. Gem of a question. Clear? When you equate all the things, this is going to be your relation. But I am telling you, please remember this relation for your GATE paper. Please remember this relation for your GATE paper. I am telling you guys, please remember this relation for your GATE paper. Now everything is known to you. The friction factors are the same, so you can cancel out F1 equal to F2 equal to F3 is equal to Fe. So you can cancel out that. Everything is the same. You can find out so DE is basically given as 0.50. LE you can find out as 377.37 meter. So what I am suggesting you, kindly remember this formula for your GATE paper. Clear guys? Yes, wonderful. आ जाओ नेक्स्ट क्वेश्चन. रुकना नहीं है. ओ हो एक और जबरदस्त प्रॉब्लम यार, एक और जबरदस्त प्रॉब्लम बोर्ड पे है. रीड करो. कम ऑन गाइस. आज हम रुकेंगे नहीं, लगभग 9:30 तक चलेगा. आज खाना वाना थोड़ी देर तक भूल जाओ. फूड वगैरह जो भी है वो थोड़ी देर के लिए भूल जाओ यार. हिलो मत. फ्लूइड मैकेनिक्स, लेट अस एंजॉय यार. टॉप क्वालिटी. वेरी गुड. आ जाओ. द मैक्सिमम पावर ट्रांसमिटेड बाय द जेट. Discharging through the nozzle, this and this. Beautiful problem. See, in my classroom I have derived the formula for diameter. So this is the jet. Let the diameter of the jet is some dj and diameter of this pipe is some d. So there is this reservoir having a head reservoir of H and water jet is coming out from here. Okay. So how to find out the he is asking for the maximum power which is getting transmitted, but power everybody knows how to find the power. Power will be WQ into H. But this discharge you will be able to, this is the discharge of the jet. So discharge you will be only able to find out when you find out the area of the jet multiplied by the velocity of the jet. है ना dear? But the important thing is how to find this area of the jet. For finding the area of the jet, you need to find out the diameter of the jet for maximum power transmission. In my classes, beautifully in every batch I have derived the condition for the. मैं आपको थोड़ा रिवाइज मैं पूरा डेरिवेशन तो नहीं करूंगा, मैं आपको रिवाइज करवा देता हूं. कैसे करते थे हम लोग. यहां पर इसका एरिया A और वेलोसिटी V लिया, इसका एरिया AJ एंड वेलोसिटी VJ लिया हमने, DJ VJ करके कॉन्टिन्यूटी इक्वेशन लगाते थे. एरिया इंटू वेलोसिटी इज इक्वल टू AJ इंटू VJ करके हैं. टोटल हेड अवेलेबल इज H. total head available is H. But for what is the condition for maximum power transmission? Condition for maximum power transmission is that the head loss, or the condition for maximum power transmission is that the total head should be 3 times the head loss. So condition for maximum power transmission is that the head loss should be head by 3. This means if you want to develop maximum power from this jet, okay, then this much head should get lost, H by 3. Then what is it? The total head available was H. For maximum power transmission, H by 3 has to get lost. So how much head is available for power conversion? Head available for power conversion is 2H by 3. And H by 3 can again be written as HL, so this is actually 2HL. Clear, guys? What a beautiful problem. And from here we find the value of head loss, we replace as FLV square by 2GD, and then from there we find the value of Vj from here and we replace the value here in this equation, and from here we find the value of Dj. We find the value of Dj. Do you guys remember what is the value of Dj? Come on guys, my classroom students, at least you should be knowing here. What is the value of Dj? D to the power 5 divided by 2FL raised to the power 1 by 4, if you guys remember. Where D is the diameter of the pipe, 2F friction factor, L is the length. Now there is no issue, everything is given to you in the problem. Everything is given to you in the problem. See, the length is given to you, diameter is given to you, है ना? Everything is given to you. So can you find the diameter of the jet from here? Yes. Once you find the diameter of the jet, I will tell you the answer. The diameter of the jet will come out to be 5.069 into 10 to the power minus 4 meter is the diameter of the jet. Okay, wonderful. Look here. But wait, you need to find out the velocity of the jet also. See, the head available at the nozzle is 90 meter. I think it is given in the, yes, it is 90 meter. Is the head available. So head, whatever is the head available to the nozzle, there are no losses in the nozzle because it is not written in the question. So the complete head will get converted to the kinetic energy, will get converted into kinetic energy. So V square by 2G is actually equal to 90. So from here you can find the velocity of the jet, which is 42.02 meter per second, and the question is over. Velocity you know, diameter you know, put here, H you know, find the power. The power will come out to be 18.805 kilowatt. I request you guys that you kindly remember this formula. Kindly remember this formula. मैं बता रहा हूँ बेटा, आ जाएगा. मैं बता रहा हूँ बच्चों, आ जाएगा, फंस जाएगा. किसी भी दिन फंस जाएगा ऐसा कुछ जो कि अनोखा होगा, अलग होगा, फिर आप हाथ पे हाथ धर के बैठे रहोगे, वो ठीक बात नहीं है, वो ठीक बात नहीं है. काइंडली रिमेंबर दिस फॉर्मूला. दिस इज द फॉर्मूला फॉर डायामीटर ऑफ द जेट फॉर maximum power transmission. Wonderful. Okay. Yes. See, now मैं थोड़ा सा और फास्ट मूव करूंगा. सिर्फ अब मैं सिलेक्टेड क्वेश्चंस, बिकॉज बहुत सारे क्वेश्चंस मैंने प्लान कर रखे हैं, बट अभी मैं और सिलेक्टेड करूंगा बिकॉज टाइम इज बिकमिंग अ कंस्ट्रेंट. ओके, टाइम इज बिकमिंग अ कंस्ट्रेंट, तो मैं और सिलेक्टेड करूंगा क्वेश्चन. देयर आर दिस 2 रिजर्वेयर्स आर देयर. द हाइट डिफरेंस बिटवीन द रिजर्वेयर इज 15 मीटर. And everybody knows this 15 will be able to overcome the losses in the pipe, but in between there is a pump is given, and pump is going to give energy to the fluid, and that is 20 meter. Getting my point, bachcho? Yes, that is 20 meter. So therefore apply the general Bernoulli's equation between A and B. Or if you don't want to apply the Bernoulli's equation, this is energy given to the fluid. So how much head is actually available for making the fluid to flow? See, 15 meter is the, this is an important question, this is an important question. Look here on the board, look here on the board, this is 15 meter and this is 20 meter, this is energy available. So total head available is 35 meter for making the fluid to flow, and that should be equal to the loss in the pipe, FLQ square by 12d to the power 5. Everything is given in the question, the length is given, diameter is given, this is given. So we need to find out the discharge from here. Discharge will come out to be 0.0922 meter cube per second, and that's your answer, and that's your answer. Beautiful problem here, mind blowing problem again. Very good, very good. Someone will say, sir, how have you written 35 here? You are very simple, apply Bernoulli between this and this, you will get the same thing. This is A, this is B, apply Bernoulli, but generalize Bernoulli's equation. What is generalized Bernoulli? P1 by W plus V1 का square by 2G plus Z1 plus पंप वर्क लेफ्ट साइड में आता है और टर्बाइन वर्क अगर कुछ है क्वेश्चन में तो वो राइट में आता है. सो दिस इज P2 बाई W प्लस V2 का स्क्वायर बाय 2G प्लस Z2 प्लस हेड लॉस. अब देखिए इट्स अ रिजर्वायर, सो PA एक्चुअली 1 and 2 A and B ले रखा है. सो दिस इज 0, atmospheric is 0, this is also 0, this is also 0. 2 you will take as reference, huh? So Z2 is 0, Z1 is given as how much? Z1 is 15 plus pump is 20 is equal to head loss. Again you are going to get this answer. Clear guys? Beautiful problem here, beautiful problem. This is one of the most interesting problems. This is one of the most interesting problems. Look here on the board. Let me explain to you what is the question. In the diagram I will explain. See, these reservoir variety actually flow. Why I am focusing more on flow through pipes? Because these flow through pipe questions, these are very important for any examination. Be it GATE, be it your engineering services examination. Okay. So there are two reservoirs are there. The head difference between those two reservoirs is 30 meter. Okay. And there is a pipe connected which is 3000 meter. The diameter of this pipe is given, the friction factor of this pipe is given to you guys. Okay. Now everybody knows, again if you apply Bernoulli between this and this, directly you guys know how much is the head available for making the fluid to flow in this pipe, 30. So 30 will be FL, length of the pipe is 3000. So let me write here, that is 0.04 into length of the pipe is 3000. Come on guys, show some enthusiasm. FLQ square, Q square divided by 12d to the power 5 is 12 into diameter of the pipe is 0.8 raised to the power 5. So from here we can find out the value of discharge. Let me tell you what is the value of discharge from here. The value of discharge is 0.99148. 99148 meter cube per second is the value of discharge. Now what, let me tell you what is the question. Now that fellow is telling you guys, that you need to transfer 20% more discharge by applying an additional pipe, something like this. But the beauty lies in the fact that whenever you want to transfer some additional discharge, okay, what you need to do is, when you need to transfer some additional discharge, you should go for pipes in parallel. Definitely you should go for pipes in parallel. Okay dear. So this is the new pipe which I have attached. The new pipe between P and Q I have attached. And you know the diameter of this new pipe is the same as the previous pipe. But what that fellow is asking you, that what should be the point of connection of this new pipe to transfer 20% more discharge. See, the second pipe is to be parallel to the original pipe and it is connected to the later. At some suitable point. And you need to find out that suitable point of connection. Neglect the minor losses. So everybody knows how to solve this, bacha. Again the head available is 30. head available is 30. You know, now you want to transfer 20% more discharge in comparison to this case. So what will be the new discharge? Let that discharge be some q dash, 20% more discharge, okay, will be 1.20, will be 1.20 of the original discharge, which is 0.99148, which is 0.99148. So this new discharge that you want to transfer will come out to be 1.189 meter cube per second. This is the discharge unit. So we don't know actually where you have connected this original pipe. The starting point is the same, but where it is connected in the pipe, you don't know. So taking that length as L, so automatically the remaining length becomes 3000 minus L. And these are pipes in parallel. These are pipes in parallel. Come on guys, come on, come on. These are pipes in parallel. So 30 will be equal to if these are pipes in parallel. If these are pipes in parallel, you know, the head loss through both this pipe will be the same. So therefore, how much discharge is coming in q dash? And you know, these are similar pipes in parallel. If these are similar pipes in parallel, then the discharge in individual pipe will get equally distributed, q dash by 2 and q dash by 2. So 30 will be equal to loss in PQ plus loss in QR. What is the loss in PQ, beta? Loss in PQ will be F into L into Q dash by 2 ka square divided by 12 into D to the power 5. 12 into D to the power 5 and diameter is 0.8. 12 into D to the power 5 and diameter is 0.8. So 0.8 raised to the power 5 plus. Arey Baba, in parallel connection, the loss is not the summation of both the pipes. The loss is the individual pipe loss. And while taking individual pipe loss, you should take the discharge of single pipe itself. Come on guys. And what is the loss in QR section? Loss in QR section is FL Q dash ka square divided by 12 into 0.8 raised to the power 5. Everything is given to you in the problem. Wait, this is not L, because this section, QR section, the length is how much? 3000 minus L. This is 3000 minus L. Okay, so from here you can calculate the value of L, and the value of L will come out to be, approximately 1218.57 meter. 57 meter. My dear students, come on. So that's our answer. You can cross check. देखो बच्चों, अगर स्पीड आप मैचअप नहीं कर पा रहे हो, कोई दिक्कत नहीं है, ठीक है. क्वेश्चंस आर अवेलेबल टू यू. आप रिकॉर्डेड से फिर से आप ट्राई कर लेना सारे के सारे क्वेश्चंस को. टाइम इज बिकमिंग अ कंस्ट्रेंट. नहीं तो मेरे पास बहुत सारे क्वेश्चंस अभी रिमेनिंग है. ये देखो, बहुत सारे क्वेश्चंस अभी रिमेनिंग है, लेकिन टाइम इज बिकमिंग अ कंस्ट्रेंट. सो इसीलिए I will discuss some selected set of questions only. ये flow through pipe वाला section is very important. Laminar flow through pipe is very important for GATE examination. That's why I am giving you this section, and few more important question. 9:30 तक देखेंगे कितना कर पाते हैं. We will continue till 9:30. 9:30 तक देखते हैं कितना कर पाते हैं, ठीक है. नहीं तो फिर मैं आपको questions दे दूंगा. You try those questions. At a sudden expansion of water in a pipeline, sudden expansion of water in a pipeline from a diameter of itna to itna, the what a question yaar, what a question. The hydraulic gradient line rises by 10 mm. Find the discharge in the pipe. So you know from, I hope you guys know what is hydraulic gradient line. A hydraulic gradient line is the line formed by joining the piezometric heads in the flow. Is the line formed by joining the piezometric heads in the flow. And you know, this pipe is having a diameter itna, it is having a diameter of 0.48, okay. And from here to here the hydraulic gradient line falls because the pressure is falling. But in the sudden expansion zone, when the fluid comes from smaller diameter pipe to larger diameter pipe, then it expands suddenly. When it expands suddenly, area increases suddenly, so the velocity decreases. Velocity decreases, so the pressure increases. Velocity decreases, so the pressure increases. When the pressure increases, there is a sudden jump in the hydraulic gradient line, and this jump is given in the question. How much? 10 mm. How much is this jump given in the problem, beta? How much is the jump given in the question? 10 mm. Fantastic problem. So again, अभी आपने derivation type का किया. Let this section be 1. Let this section be 2. Okay. See, this jump is given as 10 mm. Okay. So therefore, you know where will be the piezometric head will be more. So if this is 1 and this is 2, piezometric head at 2 will be more. Piezometric head at 2 will be more, बच्चों है ना. So piezometric head at 2 will be more. So basically, what is this 10 mm? This 10 mm is 10 into 10 to the power minus 3 is the rise of HGL. And rise, look at the language, rise of HGL means rise of piezometric head. Rise of piezometric head means value of P2 by W plus Z2 minus P1 by W plus Z1. Clear, guys? Yes, yes, yes. So basically this is rise of. Now how to find, beta? Simple. Apply Bernoulli's equation between 1 and 2. Apply Bernoulli's equation between 1 and 2. So when you are going to apply Bernoulli's equation between 1 and 2, this is going to be P1 by W plus V1 ka square by 2G plus Z1 is equal to P2 by W plus V2 ka square by 2G plus Z2 plus head loss due to sudden expansion, which is V1 minus V2 ka whole square by 2G. V1 minus V2 ka whole square by 2G. This and this is also gone already. अच्छा, gone क्यों कर रहे हो यार? Gone क्यों कर रहे हो? Piezometric head difference already you guys know is this much. Can you find the velocity from here? But you will have two unknowns. See, the calculation is your responsibility. You will have two unknowns here, that is V1 and V2. How to interconvert? Fantastic question. A1 V1 is equal to A2 V2. From here, find the relationship between V1 and V2. Put this in this. P2 by W plus Z2 minus P1 by W plus Z1 value you already know is 10, this thing. So replace by that. Okay. So finally you are going to get your answer, and that answer either you are going to find out value of V1 or either you are going to find out the value of V2. I am giving you answer. V2 will come out to be 0.181 meter per second. Okay. And discharge will come out to be A2 into V2, and it will come out to be 0.0327 मीटर क्यूब पर सेकेंड. फैंटास्टिक क्वेश्चन यार, अव्वल दर्जे का सवाल है, अव्वल दर्जे का सवाल है. अरे वाह, कुछ कुछ लोगों ने सही किया है, कुछ कुछ लोगों ने करेक्ट किया है. बहुत ही उम्दा बच्चों, बहुत ही उम्दा बच्चों, बहुत ही उम्दा बच्चों. ब्यूटिफुल. Look here. अच्छा, this question I am skipping. This question I am skipping. ये एक बहुत ही बेहतरीन क्वेश्चन मैंने चूज किया था, ठीक है, बट आई एम स्किपिंग दिस क्वेश्चन. एक्चुअली जनरली क्या होता है, हम लोग अपने नॉर्मल क्लासरूम में एक कांस्टेंट डायमीटर के पाइप का हेड लॉस लिखते हैं. कांस्टेंट डायमीटर के पाइप का हेड लॉस हम लिखते हैं FLV स्क्वायर बाय 2GD, है ना. FLV स्क्वायर बाय 2GD इज द लॉस इन अ कांस्टेंट डायमीटर पाइप. But this is a mind-blowing question, because in this question there is a pipe whose diameter is changing from 20 to 10. So here it is 20 centimeter diameter, here the diameter is 10 centimeter. Okay, 10 centimeter diameter. So variable diameter pipe, discharge is given, that fellow is asking you head loss. What a question yaar. What a question. What a question. नॉर्मल हम अपने नॉर्मल चीजों में हम कांस्टेंट डायमीटर के पाइप का लॉस निकालते हैं, ये हमसे वेरिएबल डायमीटर के पाइप का लॉस पूछ रहा है। कैसे करेंगे बच्चों बताओ? इंटीग्रेट करना पड़ेगा, इंटीग्रेट करना पड़ेगा, समझ रहे हो? बिकॉज द वेलोसिटी विल कीप ऑन वेयरिंग, velocity will keep on varying, so we need to integrate. So we need to integrate. I am skipping this question because थोड़ा सा काफी ज्यादा ही हाई लेवल का क्वेश्चन है, ठीक है? ये टर्मिनल वेलोसिटी का क्वेश्चन भी आई एम स्किपिंग बिकॉज और भी ज्यादा इंपॉर्टेंट क्वेश्चंस हैं, हम वो सॉल्व करने की कोशिश करेंगे। हिंट मैं दे दूंगा, इसका हिंट मैं दे दूंगा। अच्छा, कुछ बच्चे इसका हिंट मांगेंगे। इसका हिंट सिंपल है बच्चे, ये देखो यहां पर एक सेक्शन लो हैविंग अ डायमीटर ऑफ डी एट अ डिस्टेंस ऑफ एक्स फ्रॉम द इनलेट, ठीक है? ये कांस्टेंट डायमीटर जो आप यहां पर लिख रहे हो, कांस्टेंट डायमीटर जो आप यहां पर लिख रहे हो, इस सिमिलर ट्राइंगल की मदद से, मैं हिंट्स दे रहा हूं आपको, ये देखो सिमिलर ट्राइंगल की मदद से यहां ये इफ दिस एंगल इज थीटा, दिस एंगल इज ऑल्सो थीटा, सो सिमिलर ट्राइंगल की मदद से आप क्या लिख सकते हो? अगर मैं पहले इस वाले ट्राइंगल की बात करूं, इस वाले ट्राइंगल की बात करूं, तो सिमिलर ट्राइंगल की मदद से आप क्या लिख सकते हो? सिमिलर ट्राइंगल की मदद से आप ये वाली साइड को क्या लिख सकते हो? यू कैन राइट d1/2 माइनस d/2 डिवाइडेड बाय x, divided by x. So basically we have done this by this. Now take the bigger triangle, similar triangle we are using. Now take the bigger triangle, bigger triangle, bigger triangle. So bigger triangle, this side, how much you will write? This is going to be d1/2 minus d2/2 minus d2/2 divided by L. From this particular equation, listen to me carefully, this is a fantastic problem यार। नॉर्मल बस की बात नहीं है नॉर्मल बस की बात नहीं है लोगों के, ठीक है? इधर देखो, सो देयरफॉर यहां से हम लोग d का वैल्यू निकालेंगे। जब आप कैलकुलेट करके यहां से d का वैल्यू निकालोगे, वो आएगा d1 माइनस d2 डिवाइडेड बाय L इंटू x. This is the value of the section D. Okay. Now, for our particular question, D1 value is given as 20 centimeter, D2 value is given as 10 centimeter. Okay, and length is given to be as how much? Yes, length is not mentioned. Actually, length is given to be as how much? Yes, 10 meter is the length. 10 meter is the length. Okay, dear. So, can you find the value of D from here? So, D1 is how much? 20 minus 10 divided by length. Length is how much? 10 into x. But remember, you have put this in centimeter. To convert into meter, you should divide by 100. You should divide by 100. So from here, can you get the value of D? Yes. The value of D will come out to be 20 minus x divided by 100. This will be in meter, is the value of D. Once you get the diameter of this section, then you integrate. How do you integrate this, beta? How do you integrate this? How do you integrate for this small particular section, let us say having a length of dx, let us find the small head loss. So small head loss will be F into length of that small section is ds, FL V square or Q square, something like that you guys take. So constant discharge दे रखा है ना, तो Q square ले लेते हैं, FL Q square divided by 12 into D to the power 5, and the diameter of this particular section already you have found it out as, बेटा करना घर पे, इसको सॉल्व जरूर करना, बहुत मजेदार और उम्दा क्वालिटी का क्वेश्चन है. So this is going to be 20 minus x by 100. Okay dear, x वाले टर्म्स को अलग ले लीजिए, बाकी सब कांस्टेंट है, बाहर निकाल दीजिए, इंटीग्रेट कर दीजिए 0 से 10, इंटीग्रेट कर दीजिए 0 से 10, यू आर गोइंग टू गेट योर आंसर. मैं फाइनल आंसर लिख देता हूं, हेड लॉस आपका आएगा, फाइनल आंसर लिख देता हूं, हेड लॉस आपका आएगा रेस टू द पावर 5 है बच्चे, रेस टू द पावर 5 है ना, 12 d टू द पावर 5 होता है ना. सो फाइनल आंसर आपका आएगा 0.968 मीटर विल बी द हेड लॉस, 968 मीटर विल बी द हेड लॉस. अच्छा, अभी ये लुक एट दिस क्वेश्चन, आई एम जस्ट गिविंग यू हिंट एंड द आंसर. I am just giving you hint and the answer. See, there is this spherical ball is there which you have left into the fluid, assuming that the Stokes law is applicable, find the terminal velocity. अभी terminal velocity क्या होता है? जब आप sphere को छोड़ेंगे तो initially it is going to settle down at a faster rate, है ना? But you know, while settling down at a faster rate, after some time the forces on the sphere will balance out. Once the forces on the sphere will get balanced out, this is going to come down at a constant speed. It is going to come down at a constant speed, my dear students, and that velocity will be called as terminal velocity. So what will be the forces on this? See, the weight of the sphere will act in downward direction, buoyancy force will act in upward direction, and you know it is a sphere which is coming down, so the drag force over the sphere will come in upward direction. So on balancing the forces, what you will get? Drag on the sphere plus the buoyancy force is equal to the weight of the sphere. Drag on the sphere, a sphere moving in a fluid, assuming that the Stokes law is applicable, because for Stokes law, you know, CD value is 24 by Reynolds number. And how to find out drag force? Drag force is CD into half rho A U infinity square. सब पढ़ाया गया है क्लास में यार, रिवाइज करो यस, हाँ, टेक्निकल टिकल लगा दिया बेटा, पावर 5 लगा दिया है, क्रॉस चेक कर लीजिएगा, क्रॉस एग्जामिनेशन. देखो बच्चों, मैं बहुत फास्ट मैनर में मूव कर रहा हूं, सो बोर्ड पे कुछ चीजें हो सकती हैं, वो क्रॉस एग्जामिनेशन इज योर रिस्पॉन्सिबिलिटी. Cross examination is your responsibility. When you put each and everything you would have studied in classroom, the drag force over a sphere settling down in a tank is actually 3 pi mu u infinity into diameter is the drag. So this is 3 pi mu u infinity into diameter. Buoyancy force is rho of the fluid into g into 4 by 3 pi r cube, and weight, as it is a completely submerged, so volume submerged total, weight will be rho of the ball into g into volume of the ball, which is again 4 by 3 pi r cube. Clear guys? So from here what will be terminal velocity? U infinity. Find the value of u infinity. Let me tell you the answer. It will come out to be 49.98 mm per second. It will come out to be 49.98 mm per second. Excellent students. हाँ भाई, जिंदा हो आप लोग? Are you guys alive? आधा घंटा और क्वेश्चंस करेंगे यार, मन में है कुछ और, वैसे तो बड़े सारे क्वेश्चंस हैं, लेकिन मन में है तो आधा घंटा और क्वेश्चंस करेंगे, हाफ एन आवर और क्वेश्चंस करेंगे. Are you guys alive? Tell me in the comment box. I just need serious students to attend this lecture. I want only serious students to attend this lecture, because you know, immature जो students हैं उनको प्रॉब्लम होगा जी, प्रॉब्लम होगा. If you are not well aware of your fluid mechanics, प्रॉब्लम होगा, बिल्कुल होगा. हाँ, सर टिल 10 PM. हाँ भाई, बिल्कुल. चलो. ये देखो, बाउंड्री लेयर का क्वेश्चन है. कैलकुलेट द फ्रिक्शन ड्रैग. ओके, मतलब ड्रैग फोर्स फाइंड आउट करना है आपको ओवर द प्लेट हैविंग who is 0.15 meter wide and इतना मीटर long, placed longitudinally, lengthwise placed है plate in a stream of oil having a free stream velocity of 6 meter per second. Also find the boundary layer thickness and shear stress at the trailing edge of the plate when specific gravity of the fluid and the kinematic viscosity is given in the problem. मैं पहले ही बोल रहा हूं, ओनली सीरियस स्टूडेंट्स. चलिए इधर देखिए. देखो बच्चों, कभी कभार तो मिलते हैं यार यूट्यूब पे, कभी कभार ही मिलते हैं यूट्यूब पे. लेट अस मेक दिस सेशन ऑसम यार, लेट अस मेक दिस सेशन ऑसम. लुक एट द क्वालिटी ऑफ द क्वेश्चंस. एक फ्लैट प्लेट है विच इज केप्ट इन अ स्ट्रीम ऑफ फ्लूइड, फ्री स्ट्रीम वेलोसिटी आपको दे रखा है, स्पेसिफिक ग्रेविटी ऑफ द फ्लूइड दे रखा है, ये काइनेमेटिक विस्कोसिटी ऑफ लेंथ वाइज इन द फ्लो। आप इसको कीप कर रहे हैं, सारी चीजें आपको निकालनी है। आपसे वो ट्रेलिंग एज पे बाउंड्री लेयर का थिकनेस पूछ रहा है। देखो बच्चों, सबसे पहली बात, हमें उसने वेलोसिटी प्रोफाइल नहीं दिया, और जब उसने हमें वेलोसिटी प्रोफाइल नहीं दिया है, सो अनफॉर्चुनेटली हमें ब्लॉशियस इक्वेशंस का प्रयोग करना पड़ेगा। कुछ याद आ रहा है? भूली बिसरी यादों में ब्लॉशियस साहब थे भूली बिसरी यादों में ब्लॉशियस साहब थे कहीं ना कहीं। तुम्हारे रजिस्टर के पन्ने पलटो जरा, दिखाई देंगे खुद दिखाई देंगे खुद ब्लॉशियस साहब। ट्रेलिंग एज, सो बेटा जहां पर फ्लूइड आके टकराता है ये लीडिंग एज है, ठीक है, और ये क्या है? ट्रेलिंग एज है। ये क्या है? ट्रेलिंग एज है, ठीक है। सो देयरफॉर पहले तो ट्रेलिंग एज पे, अच्छा अब इसके ऊपर भाई स्टार्टिंग में ग्रोथ ऑफ बाउंड्री लेयर, लेमिनार बाउंड्री लेयर होता है, लेकिन वो टर्बुलेंट सी में कन्वर्ट भी तो हो सकता है इफ इट क्रॉसेस द क्रिटिकल रेनॉल्ड्स नंबर ऑफ 5 लाख फ्लैट प्लेट के लिए ना। सो सबसे पहले तो यू शुड चेक व्हाट इज द रेनॉल्ड्स नंबर एट द ट्रेलिंग एज। नाउ हाउ टू फाइंड आउट द रेनॉल्ड्स नंबर एट द ट्रेलिंग एज? रेनॉल्ड्स नंबर एट द ट्रेलिंग एज विल बी x इक्वल टू l। रेनॉल्ड्स नंबर एट x इक्वल टू l, लीडिंग एज से जो भी डिस्टेंस हम नापते हैं विद दैट इज x, है ना। सो रेनॉल्ड्स नंबर एट द ट्रेलिंग एज इज गोइंग टू बी रो वी एल बाय म्यू, विल बी रो वी एल बाय म्यू, बट हम v नहीं लिखते हैं, हम बाउंड्री लेयर थ्योरी में यू इंफिनिटी लिखते हैं, फ्री स्ट्रीम, रो यू इंफिनिटी एल बाय म्यू, एवरीथिंग इज गिवन टू यू। एल का कितना वैल्यू लेंगे बेटा ट्रेलिंग एज के लिए? 0.45। रो आपको दे रखा है, सारी चीजें आपको दे रखी हैं। व्हेन यू आर गोइंग टू कैलकुलेट दिस ना बच्चा, दिस विल कम आउट टू बी 30,000, एंड 30,000 इज वे लेस देन द क्रिटिकल रेनॉल्ड्स नंबर। दिस सिग्निफाइज दैट एट द ट्रेलिंग एज द बाउंड्री लेयर इज अ लेमिनार बाउंड्री लेयर। Now, if it is confirmed that it is a laminar boundary layer, then find the value of delta. What is the value of delta at the trailing edge? What is the value of delta at the trailing edge according to your Blasius? What is the Blasius equation? 5x divided by under root of Reynolds number. But listen, he is asking you the boundary layer thickness at the trailing edge, so you should put in place of x, you should put L, and Reynolds number also you should put at the trailing edge. Clear guys? So you will get the value of delta from here. The delta value at the trailing edge at x equal to L will come out to be 13 mm. I am giving you the answers. This will come out to be 13 mm. CD value also you can find out. CD is 1.3 for laminar boundary layer. लेमिनार और टर्बुलेंट के फॉर्मूले अलग होते हैं ब्लॉशियस के लिए, ठीक है, याद होने चाहिए आपको, मुंह जबानी याद होने चाहिए, बिल्कुल मुंह जबानी याद होने चाहिए। CD का वैल्यू आएगा अंडर रूट ऑफ रेनॉल्ड्स नंबर, ठीक है, यही होता है ना। सो CD का वैल्यू अपना आ जाएगा, दिस इज गोइंग टू बी 7.667 इंटू 10 टू द पावर -3। CD मिल गया तो ड्रैग ऑन द प्लेट निकल जाएगा। सो ड्रैग ऑन द प्लेट इज गोइंग टू बी CD into half rho a u infinity square. Remember, this is your drag on one side of the plate. If he is asking for both sides of the plate, multiply it with 2. If he is asking for both sides of the plate, multiply it with 2. Clear guys? Yes, wonderful, wonderful. So therefore, यहाँ से आप ड्रैग निकालोगे तो आपको आंसर मिल जाएगा, ठीक है, सिंपल सा है, कर लेना। एंड वॉल शियर स्ट्रेस निकालने को कह रहा है। वॉल शियर स्ट्रेस कैसे निकलता है? CFX से, CFX से स्किन फ्रिक्शन कोफिशिएंट, स्किन फ्रिक्शन कोफिशिएंट से निकलता है वॉल शियर स्ट्रेस। कितना होता है? CD का हाफ होता है। अरे ये भी रिलेशन बता रखा है, ये भी रिलेशन आप लोगों को कक्षा के अंदर बताया गया है। सो CFX इज गोइंग टू बी 0.664 of under root of Reynolds number at whatever location he is asking. You can find out and from CFX you can find out the wall shear stress. Okay, wonderful. चलिए अगला क्वेश्चन। This one is my favorite. This one is my favorite. This one is my favorite. आ जाओ इधर देखते हैं। जितने मैक्सिमम डिस्कस कर सकते हैं करते हैं यार, जितने मैक्सिमम डिस्कस कर सकते हैं करते हैं। आओ इधर देखो, टाइम इज लिमिटेड। There is a laboratory विंड टनल इज देयर, है ना, 305 mm स्क्वायर है उसका डायमेंशन. बाउंड्री लेयर वेलोसिटी प्रोफाइल, only those students will be able to solve this question who are well aware, only those students will be able to solve this question who are well aware about internal flows. So at a particular section the free stream speed is 26 and the displacement thickness delta star is 1.5 mm. At some section 2 the displacement section is 2.1 mm. Okay, then calculate what he is asking. Yes, calculate the static pressure change and all this stuff. Let me give you the hint to solve this question, because my classroom student will understand what sir is doing on the board. Classroom student will be easily under. This is a laboratory wind tunnel is there. This is the entry of the wind tunnel, and this is the exit of the wind tunnel. This is the exit of the wind tunnel. Everybody knows, and air is coming in from here, and this is 305 mm, I think, है ना? What is the dimension? Yes, 305 mm square. So this is 305. This side is 305 mm, and this side is also 305 mm. So both the sides are 305 mm square. Now that fellow is saying, first of all, let me make you revise internal flows. Look here, look here. क्या करूं यार, टीचर हूं ना, मन नहीं मानता है. पता नहीं तुम लोगों को आता है कि नहीं आता, समझ आ रहा है मैं क्या बोल रहा हूं. इंटरनल फ्लोज में जब एंट्री करता है फ्लूइड का फ्लो, तब एट द एंट्री द वेलोसिटी इज u infinity. At the entry the velocity is u infinity, है ना, velocity is u infinity. But as we move forward the boundary layer keeps on increasing, the boundary layer keeps on increasing. और इस वाले रीजन को हम लोग क्या कहते हैं, डेवलपिंग फ्लो, है ना, याद आया. और इसके आगे के रीजन को डेवलप्ड फ्लो, फुल्ली डेवलप्ड फ्लो कहते हैं, है ना, फुल्ली डेवलप्ड फ्लो कहते हैं. सो देयरफॉर यू नो, एंड दिस from here to here the profile is not constant, the profile will keep on varying, but this is inviscid core region. याद करो सारे explanation. Inviscid core region. Come on guys, let us make this session awesome. Inviscid core region होता है ये, लेकिन यहाँ पर velocity profile becomes constant. So therefore you know that fellow is saying in this wind tunnel at a certain location you have taken some section 1, and at some another certain location you have taken some section 2. Now you guys tell me whether at section 1 and section 2 boundary layer will be there or not be there. Boundary layer will be there, and if boundary layer is there at section 1 and 2, you know, to represent that thing, displacement thickness is going to come into the picture. Classroom students will understand what sir is doing. So for section 1, let me show by green. So for section 1, you know the displacement thickness is how much at section 1? 1.5 mm. So this is 305 cross 305, but you are shifting the walls such that this much mass flow rate is blocked. Come on guys, this is not for immature students. This is a very serious problem. So delta star from each wall, from 1.5, 1.5. So the side is getting reduced to 302 mm cross 302 mm. Are you guys getting my point? Clear? And once the effect displacement thickness is something which represents the loss of mass flow rate. So already you have taken care of the loss of mass flow rate. So whatever is remaining area through that, whatever is flowing is outside boundary layer, outside the effects of boundary layer. But of course everybody knows at the entry if the velocity is u infinity, then in the inviscid core region velocity will be u1, and u1 will be greater than u infinity to compensate the loss of mass flow rate in the. सब बहुत स्ट्रॉन्ग टॉपिक्स हैं यार, बहुत स्ट्रॉन्ग टॉपिक्स हैं ये सब. आप समझिए बात को, ये सब बहुत डीप टॉपिक्स हैं. और यहाँ सेक्शन 2 पे बाउंड्री लेयर और विशाल का रूप धारण करेगी 305 क्रॉस 305. यहाँ पर जब बाउंड्री लेयर बहुत ज़्यादा है तो उसको रिप्रेजेंट करने के लिए, लॉस ऑफ मास फ्लो रेट रिप्रेजेंट करने के लिए डेल्टा स्टार की वैल्यू भी और ज़्यादा होगी, है ना. सो वो दे भी रखा है 2.1 mm. So 2.1 mm on this wall, what a question yaar, mind blowing question. 2.1 mm on this wall and 2.1 mm on this wall is 4.2 mm. अभी 4.2 mm हो गया, 4.2 mm हो गया, so this is 302.8. साइड क्या हो गई 302.8 क्रॉस 302.8 and let the speed here is some u1, speed here is some u2. Continuity equation must be satisfied, that is a1 u1, that is a1 u1 is equal to a2 u2. Beta, this is the area which is remaining through which the flow will happen. I think u1 is given, u1 is given as how much, 26 meter per second. Can you from here, can you find the value of u2? Yes. So u2 will come out to be, yes, I am having the answer. This will be 26.21 meter per second. Fantastic question. But wait, he is not asking this. Come on guys, जाग जाओ, जाग जाओ, जाग जाओ. भाई वो ये पूछ ही नहीं रहा है, वो पूछ रहा है pressure drop from section 1 to 2. Now you see at the central core region you take 0.1 and you take 0.2. Do you know this central core region 0.1 and 2 that you have taken is outside boundary layer? So you can apply the classical Bernoulli's equation. Apply Bernoulli's equation between 1 and 2. Z1, Z2 will get cancelled out. Huh? What a question. P1 minus P2 by W. Can't you find here? Can't you find? Yes. Wonderful बच्चों. Okay. आओ एक और देखते हैं. Yes, yes, yes. This is our question. This is our question. Steady laminar boundary layer है, u infinity का value है 30 meter per second and the flow over the plate is parabolic, and at the trailing edge the boundary layer thickness is given as 4 mm, density is given as इतना and this is given as इतना. ये देखो ये वाले क्वेश्चन तो यार क्लासरूम में भी 2 सेकंड में झटपट, लेकिन आपको याद होनी चाहिए कुछ चीजें, आपको याद होनी चाहिए कुछ चीजें. 2 things he is asking you. Come on guys, classroom students, झटपट आंसर. You guys know. Yes. नहीं, निशांत, निशांत 305 mm का स्क्वायर है, समझ रहे? अगर उसे टोटल एरिया लिखना होता तो 305 मीटर और पावर में स्क्वायर लिखता ना. निशान समझ रहे हो बात को? उसने लैंग्वेज में लिखा है 305 mm स्क्वायर है. सो स्क्वायर के जो साइड्स हैं वो 305 mm है. सो क्लासरूम स्टूडेंट्स बताओ 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 बच्चों, इधर देखो मेरी बात. सो एक तो आपको निकालना है कितना मास फ्लो रेट इस AB से निकलेगा, और दूसरी चीज आपको निकालनी है व्हाट इज द ड्रैग ऑन द प्लेट. हाँ भाई बच्चों, सेकंड भर में प्रोफाइल देखो कौन सी है, पैराबोलिक. पैराबोलिक, इसके लीनियर का भी हमने क्वेश्चन किया है यार क्लासरूम में. पैराबोलिक प्रोफाइल है, पैराबोलिक. अच्छा, ये ऊपर से जो मास फ्लो रेट लॉस हो रहा है इसको कैसे निकाला जाता है, डेल्टा स्टार से. इसका बड़ा वाला डेरिवेशन भी हम क्लास में कर चुके हैं, बट यू शुड बी वेल अवेयर. एंड पैराबोलिक प्रोफाइल के लिए डेल्टा स्टार क्या होता है, डेल्टा बाय 3. एंड वट एवर इज दिस डेल्टा स्टार इज बेसिकली लॉस ऑफ मास फ्लो रेट इन दिस रीजन. मैं एक्सप्लेन नहीं करूंगा, ये सब क्लास में ब्यूटीफुली आपको पढ़ाया जा चुका है. सो एम डॉट थ्रू ए बी विच इज एक्चुअली इक्वल टू लॉस ऑफ मास फ्लो रेट इन BC. जो देखो, याद करो क्लास की चीज, जो भी मास फ्लो रेट यहां से पास नहीं कर पाएगा वही तो मास फ्लो रेट ऊपर से जाएगा, और उसी हाइट को जिससे वो मास फ्लो रेट पास करेगा उसको डेल्टा स्टार रिप्रेजेंट करता है. इट्स अ मैथमेटिकल टेक्निक. बहुत डेप्थ है चीजों में. सो एम डॉट थ्रू ए बी इज गोइंग टू बी रो u infinity delta star is the loss of mass flow rate. खत्म. Rho u infinity delta by 3, you have the value. Rho u infinity delta by 3. बेटा डेप्थ भी दे रखा है ना, ये जो प्लेट है इसका विथ भी दे रखा है. विथ कहां गया? yes, width is also, yes, 0.3 meter wide. So area will not be delta star, it will be delta star B. Getting my point? So delta by 3 into B. Everything is given to you in the question. What will be the mass flow rate through AB? 0.01476 kg per second, and that's your answer. Come on guys, how to find the drag on the plate? इसलिए कहता हूं याद रखा करो, अगर जल्दी जल्दी निकालना है तो याद रखा करो. Drag on the plate is basically the momentum passing through momentum thickness. And what is the momentum thickness? इसलिए वैल्यू डायरेक्ट याद होनी चाहिए, कम से कम लीनियर पैराबोलिक क्यूबिक प्रोफाइल्स की, कम से कम लीनियर। वेरी गुड, एक बच्चे ने सही आंसर दिया है, अभी शर्मा। आई एम वेरी हैप्पी यार, आई एम वेरी हैप्पी। व्हाट इज द वैल्यू ऑफ मोमेंटम थिकनेस फॉर पैराबोलिक प्रोफाइल 2 डेल्टा बाय 15? 2 डेल्टा बाय 15. This is the momentum thickness. Now the momentum passing through the momentum thickness will represent the drag on this. So momentum passing through momentum thickness is going to be rho u infinity square theta cross b. All the values are given to you. थीटा की जगह 2 डेल्टा बाय 15 पुट करेंगे और b का वैल्यू, b इज द विथ यार। विथ कितनी दे रखी है? आई थिंक 0.3 दे रखी है ना? ये देखो, ये रही विथ, 0.3 दे रखी है, ठीक है। Okay, wonderful. So therefore, my dear students, from here, drag force over the plate will come out to be, when you are going to calculate, will come out to be 0.177 Newton. Will come out to be 0.177 Newton. Wonderful. ये turbulent flow का क्वेश्चन है, अभी हम इसको skip कर रहे हैं, इसको skip कर रहे हैं। चलो, this will be the last question for the day यार, this will be the last question for the day. बहुत कुछ करा दिया, बहुत कुछ करा दिया, उम्मीद से ज्यादा ही मिल चुका है। लास्ट क्वेश्चन फॉर द डे, आ जाओ आ जाओ, देखते हैं कितने निपटा पाते हैं 9:30 तक। अ स्ट्रीम फंक्शन इज गिवन बाय, अच्छा एक और बात है, पीछे जो न्यूमेरिकल्स थे उनमें से ना किसी एक क्वेश्चन में ना फ्रिक्शन फैक्टर नहीं दे रखा है, कोफिशिएंट ऑफ फ्रिक्शन दे रखा है। लेट मी थिंक, शायद वो ये वाला क्वेश्चन था, इसका ध्यान रखना बेटा एग्जामिनेशन में भी। नहीं, इसमें तो एफ ही दे रखा है। एक कोई क्वेश्चन है जिसमें ना कोफिशिएंट ऑफ फ्रिक्शन दे रखा है, फ्रिक्शन फैक्टर नहीं दे रखा। तो कोफिशिएंट ऑफ फ्रिक्शन को हम लोग फ्रिक्शन फैक्टर में कैसे बदलेंगे बताओ? कोफिशिएंट ऑफ फ्रिक्शन को फ्रिक्शन फैक्टर में कैसे बदलेंगे? 4 से मल्टीप्लाई करके, 4 से मल्टीप्लाई करके बच्चों, ध्यान देना, ठीक है। सो क्वेश्चन को बड़े ही ध्यान से देखना कि किसमें कोफिशिएंट ऑफ फ्रिक्शन दे रखा है और किसमें फ्रिक्शन फैक्टर दे रखा है, ठीक है। बहुत ही इंपॉर्टेंट है, बहुत ही इंपॉर्टेंट है, देख लेना किसी क्वेश्चन में ऐसा है। एंड आई थिंक, ओके चलो ये वाला क्वेश्चन देख लेते हैं, ये वाला क्वेश्चन देख लेते हैं। ब्यूटीफुल प्रॉब्लम यार, हमने काइनेमैटिक्स का कोई क्वेश्चन नहीं किया, 2 क्वेश्चन काइनेमैटिक्स करेंगे एंड वी विल कॉल इट अ डे। 2 क्वेश्चन काइनेमैटिक्स के करेंगे एंड वी विल कॉल इट अ डे, ठीक है। द स्ट्रीम फंक्शन इज गिवन बाय, सो स्ट्रीम फंक्शन होता है साई, इज गिवन बाय 2x स्क्वायर वाई, थोड़ा डिफरेंट क्वेश्चन है, ध्यान से देखो, प्लस 3 + t y स्क्वायर, साई दे रखा है। फाइंड द फ्लो रेट, फ्लो रेट बोले तो डिस्चार्ज from the faces of the triangular prism. So this is the triangular prism, this is the triangular, actually this is a triangular prism, something like this, getting my point? So this is OB face of the prism, this is OA face of the prism, this is given as 3 meter and this is given as 2 meter. थोड़ा different question है, please board पे देखो, बहुत ही प्यारा question है। Then you know if this is, and the depth of the prism is 1 per unit depth. This is when we will talk about OB, we will talk about this, and when we will talk about OA, we will talk about this, we will talk about this. So you need to find out the discharge through OB and OA, OB and OA, wonderful. And you need to find out at t is equal to 1. Now how to solve these kind of problems? देखो बच्चों, साई का वैल्यू आपको दे रखा है, मेरी बात सुनो, साई का वैल्यू आपको दे रखा है। अगर आपको साई का वैल्यू उसने दे रखा है, अगर आपको साई का वैल्यू उसने दे रखा है, सो एवरीबॉडी नोज u विच इज x कंपोनेंट ऑफ वेलोसिटी। u का वैल्यू क्या होता है? u वैल्यू इज बेसिकली इक्वल टू माइनस ऑफ डेल साई बाय डेल y, फ्रॉम योर क्लासरूम यू गाइज नो। सो माइनस ऑफ डेल बाय डेल y ऑफ साई, साई का वैल्यू कितना है बेटा? 2x स्क्वायर y प्लस 3 + t y स्क्वायर। बेटा डिफरेंशिएशन आपका काम है, यहां से करोगे u का वैल्यू निकाल जाएगा। मैं आंसर लिख देता हूं बिकॉज आई एम रनिंग आउट ऑफ टाइम। 2x स्क्वायर माइनस 2 3 + t इंटू y आएगा, ये क्लियर। सिमिलरली v का वैल्यू क्या आएगा? डेल साई बाय डेल x, डेल साई बाय डेल x। सो डेल साई बाय डेल x सेम आप डिफरेंशिएट करोगे, क्या आएगा? 4xy आएगा। हमें वैल्यू किस पे चाहिए, t इक्वल टू 1 पे। सो t इक्वल टू 1 पे वैल्यू कैसे निकलेगी, u की वैल्यू अगर आप t इक्वल टू 1 पुट करोगे तो ये आ जाएगा -2x² -8y आ जाएगा, और v का वैल्यू आ जाएगा 4xy, v का वैल्यू आ जाएगा 4xy। क्लियर गाइस, यस वंडरफुल। अभी वो हमसे क्या निकालने को कह रहा है, डिस्चार्ज। बट अब देखो u जो है वो देखो, हाँ, अगर मुझे OB के थ्रू डिस्चार्ज निकालना है तो मुझे यहां पर u की जरूरत पड़ेगी, u की जरूरत पड़ेगी, बट u जो है वो वेरी कर रहा है, और मुझे OA के से डिस्चार्ज निकालने के लिए v की जरूरत पड़ेगी, लेकिन v वो वेरी कर रहा है, ठीक है। सो हमें इंटीग्रेशन का सहारा लेना पड़ेगा। सो हाउ टू, ब्यूटीफुल प्रॉब्लम यार, हाउ टू फाइंड आउट डिस्चार्ज थ्रू OB, discharge through OB, discharge through OB is going to be integration of u into dy क्रॉस 1। सो ये छोटा सा सेक्शन लूंगा dy का, क्योंकि वेलोसिटी वेरी कर रही है, ठीक है। सो dy क्रॉस 1, डेप्थ इज 1 मल्टीप्लाइड बाय u, एंड लिमिट्स क्या होंगी, लिमिट्स बताओ बच्चों, लिमिट्स होगी x इक्वल टू 0, तो ये तो है ही है, एंड y की वैल्यू चेंज हो रही है, y इज चेंजिंग फ्रॉम 0 टू y इक्वल टू 2, y equal to 2. Have you already got the value of u? Yes, I hope you guys can integrate. x का वैल्यू 0 पुट करना है, y का वैल्यू 0 से 2 पुट करना है. When you integrate this and put each and everything into the picture, you know you will get this as -16. Can you find the discharge through OA? Can you find the discharge through OA? Can you find the discharge through OA? Discharge through OA is similarly OA से होने के लिए V की जरूरत पड़ेगी, which will be dy क्रॉस 1 है। इंटीग्रेशन फ्रॉम दिस कहां से कहां करना है बेटा, यहां पर y का वैल्यू कांस्टेंट है, y का वैल्यू क्या है, y का वैल्यू क्या है, y का वैल्यू है 0, और x का वैल्यू चेंज हो रहा है, x इज चेंजिंग फ्रॉम 0 टू x इक्वल टू 3। कैन यू इंटीग्रेट, सिंपल, v का वैल्यू आपके पास है, इंटीग्रेट करो, जब आप करोगे इसका वैल्यू 0 आएगा। मजेदार क्वेश्चन था कि नहीं, अव्वल दर्जे का क्वेश्चन। लास्ट क्वेश्चन फॉर द डे, लास्ट क्वेश्चन फॉर द डे, इसके बाद वी विल स्टॉप यार, इसके बाद वी विल स्टॉप। आज देखो एफिशिएंसी एंड इफेक्टिवनेस इज द मोस्ट इंपॉर्टेंट थिंग। आओ पहले तो ये क्वेश्चन निपटाते हैं, फिर थोड़ी सी बात करेंगे। फाई का वैल्यू दे रखा है, आपसे साई का वैल्यू पूछ रहा है, मैं आंसर्स आपको बता दूंगा। वी विल यूज द कॉशे-रीमान इक्वेशन। व्हाट इज द कॉशे-रीमान इक्वेशन, डेल फाई बाय डेल एक्स इज इक्वल टू डेल साई बाय डेल वाई। दिस इज द फर्स्ट कॉशे-रीमान इक्वेशन। सेकेंड कॉशे-रीमान इक्वेशन क्या होता है, माइनस ऑफ डेल फाई बाय डेल वाई इज इक्वल टू डेल साई बाय डेल एक्स। सेकेंड, तो देखो बेटा फाई दे रखा है, आपको साई निकालना है, फाई दे रखा है, आपको साई निकालना है, तो आप क्या करोगे, साई का वैल्यू निकालोगे, साई का इक्वेशन निकालोगे, दोनों सीआर इक्वेशन। दोज ऑफ यू हु आर माय स्टूडेंट, दे नो हाउ टू कैलकुलेट, दे नो हाउ टू कैलकुलेट, ओके। सो साई का वैल्यू निकल जाएगा, फिर अपने को क्या निकालना है, फ्लो रेट विच इज डिस्चार्ज, विच इज डिस्चार्ज बिटवीन वन। व्हाट इज डिस्चार्ज, डिस्चार्ज इज बेसिकली डिफरेंस ऑफ द stream function, that is psi whatever, psi 2 minus or psi 1 minus psi 2, psi 1 minus psi 2 at this particular points। psi का वैल्यू निकल जाएगा, जो भी psi का वैल्यू निकलेगा उसमें x की वैल्यू 1, y की वैल्यू 1 पुट करना, और आप पुट करना 1 और 2 पुट करना, ठीक है। यू विल गेट psi दिस एंड दिस, सब्सट्रैक्ट कीजिएगा, आपका क्या आ जाएगा, डिस्चार्ज। मैं आपको आंसर बता देता हूं, this will come out to be 6.5 units। again very very good question यार, उम्दा क्वेश्चन है, बहुत उम्दा क्वेश्चन है बहुत। एंड साई का वैल्यू भी लिख देता हूं, साई का वैल्यू आएगा 2xy माइनस 3/2 x स्क्वायर माइनस y स्क्वायर प्लस कांस्टेंट। दिस विल बी द वैल्यू ऑफ दिस। सो जब आप करोगे तो वो कैंसल आउट हो जाएगा, एंड वी आर गोइंग टू डू दिस। ब्यूटिफुल यार, ओके वंडरफुल। ये कुछ नहीं है, सिंपल सा एक क्वेश्चन था। ऑलमोस्ट वी हैव डिस्कस्ड एवरीथिंग यार। ये जरूर मैं करूंगा आपके साथ, ये जरूर मैं बताना चाहूंगा, ये जरूर मैं बताना चाहूंगा, बिकॉज ये जो क्वेश्चन है ये बड़े सारे मैकेनिकल इंजीनियर्स को डाउट है। ये हमारे गेट के पेपर में भी आया था ये क्वेश्चन। सो हम लोगों को वेलोसिटी वेक्टर दे रखा है, द वेलोसिटी वेक्टर इज गिवन, द एक्सप्रेशन फॉर प्रेशर ग्रेडियंट वेक्टर पूछ रहा है वो हमसे, एक्सप्रेशन फॉर प्रेशर ग्रेडियंट वेक्टर पूछ रहा है वो हमसे। बेटा इसके लिए ना नेवियर-स्टोक्स इक्वेशन लगती है, और देखो बोर्ड पे क्या मजेदार नेवियर-स्टोक्स इक्वेशन, आप लोग हमेशा कंफ्यूज आते रहते हो। ये देखिए नेवियर-स्टोक्स इक्वेशन इज नथिंग, इट इज कौन कौन सी फोर्सेस, प्रेशर, ग्रेविटी एंड विस्कस फोर्स, एंड यहां पर कौन सा फोर्स, इनर्शिया फोर्स विच इज मास इनटू एक्सेलरेशन, combination is Navier-Stokes equation. So this is your inertia force, rho into du by dt, and this du by dt is what, total derivative. याद करो भाई, क्लास में सब पढ़ाया गया है, टोटल डेरिवेटिव। इसका एक्सपेंशन क्या होता है, तो जैसे du by dt है, इसका एक्सपेंशन क्या होगा, u into del u by del x प्लस v into del u by del y प्लस del u by del t। 2D में लिख रहा हूं, 2D में लिख रहा हूं, ठीक है। दिस इज योर प्रेशर का टर्म, दिस इज योर विस्कस का टर्म, दिस इज लैप्लासियन ऑपरेटर। बेटा लैप्लासियन ऑपरेटर का एक्सपेंशन क्या होता है, डेल स्क्वायर यू बाय डेल एक्स स्क्वायर प्लस डेल स्क्वायर यू बाय डेल वाई स्क्वायर, सब पढ़ाया गया क्लास के अंदर। दिस इज योर ग्रेविटी, दिस इज योर ग्रेविटी टर्म। सो दिस इज Navier-Stokes इक्वेशन इन एक्स डायरेक्शन, दिस इज Navier-Stokes इक्वेशन इन वाई डायरेक्शन, हुज एक्सपेंशन आई हैव ऑलरेडी टोल्ड। वाओ वाओ मैन, whose expansion is also given. Now few things which are given in the course, see now where Navier-Stokes equation is utilized, Navier-Stokes equation is utilized when the velocity field is given and he is asking for the pressure field. So pressure field बोले तो क्या, pressure field मतलब del p by del x I cap plus del p by del y j cap, इसका वैल्यू आपको निकालना है, यू नीड टू फाइंड आउट दिस वैल्यू। ओके, सो यू दिस इज गिवन टू यू वेलोसिटी, बट फ्यू इंपॉर्टेंट थिंग्स, फ्लूइड फ्लो इज गिवन एज इनकम्प्रेसिबल एंड फ्रिक्शनलेस। इफ इट इज गिवन एज फ्रिक्शनलेस देन द विस्कोसिटी टर्म्स आर गॉन, viscosity terms are gone, and you know it is 2D, it is 2D, so let us take gravity in only z direction. So gravity is only in z direction, so gx एंड जी वाई, यहां पर हम थोड़ा सा चाल चल रहे हैं, हम ग्रेविटी को z डायरेक्शन में ले रहे हैं, ठीक है। सो ग्रेविटी इन x एंड y इज ऑल्सो 0। सो यहां से बस सिंपल देखो, इसका एक्सपेंशन u और v आपको पता है कि आप डेल p बाय डेल x और डेल p बाय डेल y निकाल सकते हो, आपका जिम्मेदारी है। अब ये आपका क्या है, u है, और माइनस y आपका क्या है, v है। क्या आप du बाई डी टी और dv बाई डी टी नहीं निकाल सकते हो? करो करो इंजीनियर हो, जाग जाओ। व्हाट क्वेश्चन यार व्हाट क्वेश्चन मैन, एंजॉय यार, एंजॉय एंजॉय, व्हाट क्वेश्चन। ठीक है, आपका आंसर आ जाएगा, आपका आंसर आ जाएगा। सो माय डियर स्टूडेंट्स, with this I will end this beautiful session. Just look at the efficiency and effectiveness. एक मिनट भी टीचर नहीं बैठा, सांस तक नहीं लिया यार। पढ़ाई हर कोई करता है, लेकिन हम लोग इंजीनियर्स हैं, इफेक्टिव पढ़ाई से रिजल्ट्स आते हैं, इफेक्टिव पढ़ाई से रिजल्ट्स आते हैं। दैट इज वेरी वेरी इंपॉर्टेंट। सो आई वुड लाइक टू थैंक यू। A lot of students have literally attended the complete session, and I pray to God, I wish you all the very best for your GATE examination. If you have any doubts, any problem, you can message me personally on Telegram. If you have any doubts, anything, you can message me on Telegram on 9811524231. Okay, so I hope fantastic. But last year GTQ video, I will tag it in the comment box. You please do that, those questions also, completely different set of questions. And ये वाला GTQ तो अपने पास है ही, उसके अलावा curved surface भी मैं YouTube पे पढ़ा चुका हूँ, उसके भी beautiful questions मैंने इसमें include नहीं किए। You can solve those questions. So what a mind blowing day यार, what a mind blowing day. Complete students, इतना चिलिंग ठंड है दिल्ली में, बट टीचर इज लाइक, देखो आपको पढ़ाते पढ़ाते आई एम लाइक स्वेटिंग लाइक हेल। बट चलो, आई होप कि आज का सेशन आपको मजा आया होगा। ब्यूटिफुल सेट ऑफ क्वेश्चंस वी हैव डन, ठीक है। क्वेश्चंस एंड सॉल्यूशंस जो भी हैं, वीडियो को पॉज करते चले जाना, रिकॉर्डिंग से क्वेश्चंस नोट कर लेना रजिस्टर में, सॉल्यूशंस नोट कर लेना, सारी चीजें मैंने आपको प्रोवाइड कर दी है, ठीक है। टेल मी इन द कमेंट बॉक्स, वीडियो अभी लाइव खत्म हो जाएगा, उसके बाद कमेंट बॉक्स में टेल मी हाउ डिड यू लाइक द सेशन। ओके डियर, सो ऑन दैट नोट, दिस इज वरुण पाठक सर signing off for today. Jai Hind. Namaskar everyone.